Hello students, welcome to this paper analysis and solutions of gate mechanical engineering which was conducted yesterday. Most of you might have written the exam very well because the paper was quite easy. I would rate the paper as easy to moderate in between. In fact, most of the questions are pretty easier. This is Sekhar from Msigma Gokulam. I myself have got around 30 years of gate teaching experience since the 1995. So in the last 30 years of my gate coaching experience, very rarely I see such a easy paper. This is one of such paper, much easier than gate 2024. Actually, last year paper itself was easy. In fact, if we just see for the last 5 years, gate 21, 22, they are tougher. 21, 22 are definitely tougher papers. After that, 23 was moderate, 24 was easier, 25 is much easier. 24 was conducted by IIC Bangalore. Some of you might have written last year. This year conducted by IIT Roorkee, which was even easier than the 24 paper. Therefore, the cutoff marks may rise. The cutoff marks may go up. Those who have appeared for the 24 exam, you are very well aware that those who are scoring around 60 marks out of 100 also, their ranks were well within the 600 or 700 ranks. They may expect even the interview calls from many PSUs. As such, that was the statistics last year, GATE 2024. This year it may change quite, because when the paper was easy, most of the students would be able to answer well. There cannot be much gap between the top scorer and the average scorer. Actually, paper should be tough to my point of view, because I have been seeing this gate examination for so many number of years. When the paper is tough, there would be a clear demarcation between the student which is the brightest student and the average student and the mediocre student. There must be distinguishing. That distinguishing could happen only when the paper carries some good toughness and good weightage, and rather the paper should not be easy. After all, IIT is conducting. So such a easy paper I never expected, but it is quite easy. Most of the questions, just you can read the question, and immediately within 5 or 10 seconds, those who are prepared well, within 5 seconds you can put the answer. Like such questions, particularly in IC engines and power plant and even some fluid mechanics questions also, they are quite easier as such. And the overall weightage, if you see for all the subjects, they were distributed evenly. Not that one subject has got the more marks. For example, if you see GATE 2022, heat transfer was given 11 marks. That was unusually higher. But this year also heat transfer has got a good number. That is around 7 marks. Actually, 4 questions they were asked. In no subject has got undue extra marks. All are distributed normally. And for your information, exactly 8 days ago, I have released one video, last 1 week preparation tips for the heat transfer. Just to recall that video which I had given exactly 8 days, 8 days before. 2 questions which I have mentioned directly have appeared in this exam. One is a forced convection heat transfer problem with constant heat flux conditions, and other is the radiation network problem. Directly I have specifically mentioned in that video. Please go through these 2 models of problems, you will definitely get it. Both have appeared. And 1 month ago I had released one more video, last 1 month preparation tips for the GATE 2025, or I discussed all the subjects. Many questions have appeared in this exam. For example, strain energy problem I mentioned in the last 1 month back. I have released one video. I clearly mentioned the strain energy problems in the strength of materials. It has been given. And I also mentioned the kinematics of the fluid flow, particularly irrotationality of the fluid flow. That has been given in this gate. So whatever the points, and moreover in the casting I mentioned solidification time. I have given the extra weightage to that particular topic when I was releasing my video 1 month back. There I had mentioned in the casting, just please look at that area where the solidification time may be asked. Again, that problem has come. So most of the problems which I have given in this gate are regularly being asked. They were asked many times in the previous gate papers. Again, they are being asked. Actually, some barring 1 or 2 topics, except 1 or 2 topics like economics of the metal cutting, that was a lengthy elaborative problem was given. All other problems are quite simpler. One radiation network problem given, that is also slightly lengthy in heat transfer. That is also a bit lengthier. Other problems are straightforward. Even the strength of materials are, most of the problems they have given, the 5 problems they have given, all are straightforward. Machine design also straightforward only. but not a much toughness, which very even any average student with a good preparation would easily attempt most of the questions. Okay, so that is my opinion. That is my opinion. In my opinion, I would rate this paper as easy to the moderate. It is easier than the GATE 2024. Therefore, the cutoff may definitely will increase, and the top scorer will get much higher marks as compared to the last year. So that is actually my overall opinion about the toughness. But this such an easy paper I have not seen in the recent times for the last 5-6 years. Okay, and I would like to go. The overall actually what are the question types and given there. I would like to give the statistical data of the GATE 2025. There are 4 NAT 1 mark questions and 23 2 marks questions. Most of the NAT questions where you have to type the answer. Most of the NAT they are put in the 2 marks wing. Most of the numerical aptitude like you have to type the answer, right? No negative marking there. Most of the NAT questions were put in the 2 marks one. Most of the MCQ questions were put in the 1 mark. That is expected. Usually every GATE that happens. Generally NAT type questions will be carrying 2 marks and MCQ will be carrying 1 mark. And this year MSQ multiple selective questions, there is only 1 that is asked. Actually last year they asked 2, this year they asked only 1. So that means he is slightly reducing the multiple selective questions where you have to answer more than 1 option there. So that is what we have observed here in this paper. And all the 3 streams were given equal weightage. We have 3 streams in mechanical: thermal and fluid, mechanics and applied mechanics and design, and manufacturing and industrial. 3 wings. All the 3 wings are given generally usually 24, 24, 24. That is a weightage. But sometimes the weightage will go up to 26, 28 also in each stream. But this year he has managed all the 3 streams equal weightage. So basic thermodynamics 2 1 marks and 2 2 marks. Applied thermodynamics. In fact, basic thermodynamics questions were, I am going to discuss that. They are quite easier. All the thermodynamics questions asked are pretty easier. There is not at all a difficulty. Even applied thermodynamics even much easier. Applied thermodynamics I mean which includes power plant plus RAC plus IC. All 3 put together, the number of questions asked are in fact I think 4 questions may have asked actually. It would wrongly put up to 3 questions. There are 4 questions asked, but all are quite easier. Fluid mechanics, he has given a slightly more weightage this year, but they are not that tough. They are not that tough. Fluid machinery, and coming to the fluid machinery, or I mean to say hydraulic machinery or turbines, turbo machinery we can say. Last 3 or 4 years I have never seen a single question in the fluid machinery from the turbines or the rather pumps or whatever it is, compressors. Fluid machinery means turbines, compressors, all that put together. Pumps, everything is a turbo machinery. In the fluid machinery, no question has appeared for the last 4 years, but this year 1 question has been asked, that too in the Pelton wheel, that too regarding the Pelton wheel. If the question is on Pelton wheel, it will be naturally quite easier, because either you have to ask a Pelton wheel or a Francis or a Kaplan when you talk about the hydraulic turbines. When you go to the steam turbines, mostly you may likely to ask the de-level turbine, which is also pure impulse turbine like a Pelton wheel. They may ask, if you go to the steam turbines, most likely to be asked in the de-level turbine, which is an impulse type. In the hydraulic turbines, they have asked the Pelton wheel, which is also pure impulse type. So the question was also quite easier. Heat transfer, 1 question slightly ambiguous question he has asked actually. I will just discuss that. But 1 radiation network problem he has asked. But the surprising thing in the heat transfer is, this year he has not asked any question in the conduction. Total conduction is the biggest chapter in the heat transfer. But no question has been asked, neither in the critical radius, nor the heat generation, nor the lumped heat analysis, none of the composite slab or the cylinder, no topic. Actually, that is quite surprising. Generally, when they set a paper on heat transfer, they usually at least 1 question they give in the conduction heat transfer, because in the heat transfer subject, that is the biggest chapter. So total conduction is deleted. That is very quite surprising. No conduction here, no conduction and no conduction problem. But he has asked, generally people tough convection and radiation tougher. He has asked convection and radiation. Heat exchanger also, no conduction problem, no heat exchanger problem. They are quite surprising, but he has asked whatever the problems comes, convection has asked and radiation. So that is the surprising thing in the heat transfer. because GATE exam is quite unpredictable. See, as just see, for the last 4 years he didn't ask the fluid machinery, he has asked this year. So definitely that unpredictability is expected in the GATE examination. Sometimes you may give a undue weightage to the one particular subject, giving more than 10 marks. But in this GATE, no undue like weightage for a single subject. He has distributed among all the subjects. Okay, we got around 12 to 13 subjects. Among all the subjects, he has distributed the entire total number of marks allotted. Okay, so that is the over approximate number of marks given in each subject. Fluid mechanics slightly dominated in this particular stream. Coming to the second stream called applied mechanics and design. Applied mechanics and design. If you see here, Shanta Materials is asked 4 questions. But if you just talk about the theories of failure, that may be put up in the machine design or the Shanta Materials, because theories of failure is a junction between the SOM and machine design. You got von Mises theory, Rankine theory, Truss theory, etc. No? So that is a bridge between machine design and the Shanta Materials. I have very clearly mentioned in the 1 month ago, when I was giving the last month preparation tips, give extra weightage to the theories of failure, because that is common for both the Shanta Materials and machine design. So without the theories of failure, you would not be able to design a particular component, maybe a shaft or whatever it is, coupling or whatever the component you want to design. So we have to take the help of the theories of failure, which will be done in Shanta Materials and also in the machine design. He has asked the theories of failure. Von Mises theory he has asked. And machine design is 4 questions as asked. Theory of machines is slightly, in fact slightly tougher only. Theory of machines questions. One natural vibrations is asked actually, natural frequency and slider crank mechanism. One question is asked in the theory of machines, and also gear pinion number of teeth is asked one question in the theory of machines. And engineering mechanics, actually engineering mechanics question generally they will be tougher usually in the GATE, but this GATE they have given very easy. One truss is asked. Truss and the plain truss, that is quite easy, and the problem on pure rolling he has asked. And that is 2 questions. So that not many number of questions. Generally, sometimes engineering mechanics they give undue advantage more, but this year not many questions. But whatever the questions asked in the engineering mechanics, they are relatively easy questions. So that is the weightage of this particular second stream, applied mechanics and design, but more or less 24 to 25 marks. As I said, all the 3 streams are given more or less same number of marks weightage. And coming to the third stream, manufacturing and industrial. Manufacturing and industrial. Manufacturing and industrial, that is also material science. Only one question has been asked, that is regarding the surface hardness of the steel. That is steel surface hardness. Regarding that one question is asked. And manufacturing, when you come to the manufacturing, he has asked more in the casting. Casting he has put up 3 questions. As I mentioned, solidification time, that is a regularly asked question. So a question regarding the solidification time. Then the 1 month back also, when I in my video observed that, just watch that video which I released exact 1 month back, I am specifically mentioning Welcome back to the live session. Sorry for the interruption. There is a small technical glitch, but for that nothing else. Now coming to the third stream, he has asked only one question in the material science, that too regarding the surface hardness of the steel. And manufacturing is asked the casting 3 and one question on the economics of metal cutting. That is a lengthy economics of metal cutting. Actually, that is a in fact lengthy problem, because you have to calculate the by using the Taylor's tool life equation, that Vt to the power of n is equal to constant, the tool life and all that lengthy question they has asked, and a bit lengthy question, and that is a one question. He has asked the one welding bit, bit regarding the welding, and one farming question has asked, one farming question. Okay, I has covered all the areas as such: farming, welding, metal cutting, orthogonal metal cutting, and as well as the casting. So all the domains he has covered in the manufacturing. In the industrial, he has asked only 3 questions. He has asked only 3 questions. That is regarding the one is very commonly expected inventory and economic order quantity. That is one, and demand forecasting. One he has asked one question. And as everybody expects, CPM PET, program evaluation review technique, actually critical path method, that one critical path method, and all the 3 questions, expected questions, have come from the industrial. 3 questions from the industrial, and all the topics of the like manufacturing were covered equally without undue weightage or a particular topic, lasting slightly more. Material science 1. So that is the overall distribution. So what I mean to say is, in this particular gate, no subject got an extra undue weightage. All are equally distributed, all among all the 3 streams, and each stream all have got more or less same marks. Fluid mechanics only slightly more, 1 question or 2 questions extra. But for that, everything is evenly distributed. But most of them are quite easy, as I mentioned earlier. So this time cutoff will definitely go up. And topper will have much in last year I think topper is around 75 or so, last year 75 or around 80, but this year it may go up slightly. Okay. Now let me discuss each question in detail. First let me start with the thermodynamics. All the questions asked in the thermodynamics were quite easy. A hydrogen gas undergoing a polytropic process. The process is polytropic. That point you have to notice. That is PV to the power of n is equal to constant, where n is given as 1.3. Okay. Gamma, hydrogen gas. Actually, whenever you are attempting a thermodynamics question, look at my videos of thermodynamics videos which are given GATE coaching videos. Very specifically mentioned, you have to ask 3 inquiries. What is the nature of the gas? Is it ideal gas? Is it a monoatomic? Is it a diatomic? Etc. Number 2. What is the nature of the system, closed or open or isolated? Number 3, what is the nature of the process? So all the 3 inquiries you have to do. Here working fluid is hydrogen, that is an ideal gas. Diatomic ideal gas, hydrogen is diatomic ideal gas. Diatomic ideal gas, for which the gamma value will be 1.4. If it has given, because all this data we have collected based on the memory based. See, paper is not out. We have just collected from the students which have remembered those questions after writing the exam. After collecting that only, we have prepared this question paper. So gamma, some students have said gamma is they have taken gamma as 1.66 or 1.67. How can you take the gamma as 1.67 for the hydrogen? Because hydrogen is a diatomic. 1.66 for the monoatomic gas like a helium, neon, etc. argon. Monoatomic ideal gas 1.66. For diatomic gas like hydrogen, nitrogen, air, oxygen, etc. it is 1.4 gamma is. And what is gamma? Adiabatic index, that is Cp by Cv. And if the work done by the gas is 400 kilojoules, then the heat transfer. Somebody said work done on the gas. Actually, there was a confusion among the students, right? Because students don't really remember what is that, what is in their mind. Actually, after writing the exam, in the tension, they might have not clearly remembered that what is the data given. And I request you, all of you, that anyone of you want to chart, you can chart with me. I am ready to answer your whatever the charting you want to have, I am ready to answer. And here, what is the heat transfer? Now you have got the awareness of the process, polytropic process. In polytropic process, heat transfer is given by gamma minus n by gamma minus 1 into work done. Okay, gamma is 1.4, n is 1.3. Okay, work done is being given, work done by the gas actually 400. If it is work done on the gas, that will be minus 400 actually. So therefore Q will be equal to 1.4 minus 1.3 divided by 1.4 minus 1 into 400. That will be 100. 100 because it is given in kilojoules, answer will be in kilojoules. But one thing is certain that here if the work done by the gas, then it will be positive by the gas. If it will be negative, if it is work done on the system, compression work, it is negative. That means when W is negative, Q also will be negative. So that means if the gas is compressed, by doing the work, heat must be rejected. When this is negative, this will be negative. Supposing if the gas is expanding, work is positive and the heat must be supplied. So whatever the sign of W, same sign of Q will be having, because gamma is always greater than n here in this case. Gamma will be greater than n. So gamma is adiabatic index, n is polytropic index, gamma is greater than n. That means the sign of W will be the sign of Q. If W is negative, Q also will be negative. That is a rejection. This is a work done on the system. Supposing work done by the system, that W will be positive, then Q also will be positive, that is heat should be supplied. So answer is 100. Now going to the second question. This is a straight question. A work is done on insulated rigid cylinder. Rigid container, insulated, adiabatic. This is insulation with the help of a stirrer. This is a stirrer. Work is done. Shaft work, stirrer work. Okay. Which of the following statements are correct? Actually, the system here is Q is 0. Q is 0. Work done on the system, negative. So system is closed. It is closed system, right? If you write the first law of thermodynamics for a closed system, work done on the system, right? That means minus of minus, it will be positive. Implies delta U is positive. When delta U is positive, internal energy increase. When the internal energy increase, what is containing here? With the help of a stirrer. If you assume that it is air, internal energy is increasing, implies temperature also will increase, because internal energy is a function of temperature for ideal gas. Air is an ideal gas. When internal energy is increasing, why change in internal energy is positive? Because work is done on the system. Why I am keeping the minus here? Work is done on the system. So therefore, this minus is in the minus of the equation. Minus of minus becomes plus. That means change in internal energy is positive. Internal energy is increasing. That means implies temperature also increases. Why? Internal energy is a function of temperature only. This is only called as Joule's law. Joule's law of ideal gas. Interestingly, enthalpy is also a function of temperature only for ideal gas. For ideal gas, enthalpy is also a function of temperature. That means for ideal gas like air, both internal energy and enthalpy depend only on the temperature. That's it. So as the temperature is increasing, internal energy is increasing and enthalpy is also increasing. So one of the options I said that enthalpy increases. Fine. That is one option. How about the entropy? When you come to the question of entropy, see, entropy, if you understand entropy, you understand whole of thermodynamics. It is like that. This is an irreversible process. Identify the process, whether it is reversible or irreversible. Irreversible. Why? Because this stirrer is rotating against the viscosity of the fluid. The stirring is taking place against the viscous resistance offered by the air. That is an irreversibility. Shaft work, mechanical shaft work done, churning work is an irreversible process. Because this shaft runner, this fan or the stirrer is rotating against the viscous resistance offered by the air. The process is definitely irreversible. We know that in every irreversible adiabatic, because no heat transfer, the process is irreversible and adiabatic. Irreversible and adiabatic. Why adiabatic? Because there is no chance for the heat transfer. It is insulated. So the process is irreversible adiabatic. In every irreversible adiabatic process, the entropy of the system must increase. Process is irreversible, okay. There is no change in entropy of the surroundings, because surroundings they can't lose heat nor gain heat. Whatever the entropy change happens in the universe, that would happen only because of the entropy change of the system. Because in every irreversible, we know that delta S of the universe is definitely greater than 0 for irreversible process, that is sure. What is delta S of the universe? Delta S of the system plus delta S of the surroundings, right? Delta S of the surroundings should be greater than 0, but delta S of the surroundings is 0. Why 0 here? Because in this process, no, the surroundings neither losing heat nor gaining heat. They don't give the heat, they don't get the heat. Therefore, no change in the entropy of the surroundings. So, what that delta S of the system must be greater than 0. That is, both enthalpy increases and entropy also increases. That is the answer. Entropy and entropy both increase. Answer is A. It's a very good question. We have to apply the both first law and second law. This is second law. Delta S of the universe greater than 0 for any irreversible process. For any irreversible process, that is greater than 0. If delta S is equal to 0, I can declare that the process is reversible, undergone in the universe. Right. Now, this question is also straight question, not at all difficult at all. A heat pump is working on a reversed Carnot cycle. Okay. A heat pump is working on a reversed Carnot cycle where heat is rejected. What is the function of the heat pump? To extract the heat from low temperature and give it to the high temperature. But this rejection of the amount heat loss, this is to the room, this is 15 kilowatts. Okay, and what is the power? Because any heat pump requires power. So, any heat pump working on the reversed Carnot cycle, its COP depends only on the temperatures between which the heat pump is operating. That is a speciality of the Carnot cycle or the reversed Carnot cycle. The thermal efficiency of the Carnot cycle or the COP of the reversed Carnot cycle depends only on the temperatures between which the machine is operating. Here it is a anti-clockwise cycle, right? It is an anti-clockwise because all the heat pump cycles are a power absorbing cycles. Therefore, COP of the heat pump depends only on the temperatures. What is the COP of the reversible heat pump or the Carnot heat pump? This is the formula, HT divided by HT minus LT. HT is HT, 300 divided by 300 minus 280, that is 300 divided by 20, that is 50. COP of the reversible heat pump is 50. For any heat pump, what is the formula for the COP? Desired effect is how much? Q rejected to high temperature. Q rejected to high temperature is the effect wanted, effect sought after, divided by power. That is 15 is equal to 15 kilowatts is rejected divided by power. Power is equal to 1 kilowatt. This is answer. Power is 1 kilowatt. Power input required to drive the heat pump will be 1 kilowatt. Straight question. We just need to write the COP of the reversed Carnot cycle and equate that to the COP of any heat pump formula. Okay. It is a reversible heat pump. Reversible heat pump or a reversed heat pump working on the reversed Carnot cycle all mean the same. Okay. So, question is very straight and simple, no difficulty at all. Now, coming to the fluid mechanics. So, all the questions asked in the thermodynamics are pretty easy, quite easy, not at all difficult. Actually, they never asked such a simpler questions in the earlier papers. Look at the papers given in the 21, GATE 20, 21, just read them, they are quite tougher in thermodynamics as such. But I don't know, this year paper has come to so easy. Using Froude model. What is a Froude number? First of all, Froude number is defined as square root of inertia force by gravity force. Froude number, Froude model law they also call. It is applicable to certain cases like the flows like subjected to the open surface flows as such. Froude number is given by velocity divided by root of Lg. Okay, using Froude model law, velocity of the model is given as 1 meters per second. Then what is the velocity of the prototype? Because Froude number of the prototype is equal to Froude number of the model, that is V by root of Lg of the prototype is equal to root of Lg of the model. LP by LM was given. LP by LM was given, this ratio. Put this ratio here, G gets cancelled. Obviously, acceleration due to gravity gets cancelled. And the velocity of the model is also given 1 meters per second. Then what is the velocity of the prototype? It will be 100 meters per second. Velocity of the prototype will be 100 meters per second. Sorry, 10 meters per second. Not 100, 10 meters per second. In the dimensional analysis, when you are using a particular model law, there are different model laws are there, Euler model law, Reynolds model law. So when you are using that particular model law, that particular number, maybe a Reynolds number or a Euler number or the Froude number, they must be equated between prototype and the model as long as there is a complete similarity is existing between them. As long as they are homologous in series, these dimensionless numbers what we derive from the dimensional analysis can be equated between the prototype and model if they maintain a complete similarity, geometric, kinematic and dynamic similarities. Okay. So that is the importance of these various numbers there. So Froude model law we have used here, we got the velocity of the prototype. Okay. The velocity vector for a flow is given 3z, this is 3z I bar, this is wrongly typed, Cx k bar for an irrotational flow. This is the clue. Questions on this kind of kinematics of the fluid flow, particularly on the irrotational flow, are very common in GATE. So many times it is asked. Again it is asked, the value of this C is. Okay. For irrotational flow, this problem can be done in two different ways. For irrotational flow means ideal fluid flow, potential flow. They are good different names. Irrotational flow or the potential fluid flow or the ideal fluid flow all mean the same. For irrotational flow of fluid, curl of the velocity vector should be 0. So this is the curl of the velocity vector should be equal to the 0. So what is this velocity vector here? In fact, there is no j bar there. That means here you can say u is equal to 3z, because generally velocity vector is given by u I bar plus v j bar plus w k bar, where u, v, w are the three mutually perpendicular components along x, y and z directions. U, v, w are the three mutually perpendicular components of velocity vector along x, y and z directions. But here there is no j bar, that here v is given as, can be taken as 0, no velocity component along the y direction. Okay, that we can infer from the given velocity field. From the given velocity field we can infer that. So the curl, we know how to calculate the curl, I bar, j bar, k bar, dou by dou x, dou by dou y, dou by dou z. And here what is the u value given? U is 3z, v is 0, w is cx. Curl of the v bar is equal to 0. From this we can get the c value is 3. This is the answer. This is one of the ways of doing this problem. There is another way also. Actually, I will tell you another way. What is another way? But now from the given field, from the given velocity field, by seeing this equation, would you call that flow as 2-dimensional, 3-dimensional or 1-dimensional? I can definitely say it is a 2-dimensional flow. It is a 2-dimensional flow because there is no j bar unit vector there. The 2-dimensional flow in zx plane, in xz plane. 2-dimensional flow in xz plane. When a 2-dimensional flow in xz plane, any 2-dimensional flow can be called as an irrotational if the rotation component of the fluid element about an axis perpendicular to that plane where the flow is happening is 0. In case here for fluid flow in xz plane, if omega y is equal to 0, that is rotation component about y axis, rotation component about y axis is 0, that is then flow is irrotational. So this way also we can do. I am giving the alternate method. Instead of, if somebody may not be aware how to calculate the curl, because the calculation of curl is, again, people think that this question is in the mathematics as such. Actually it is FM question only, but you need to know some mathematical techniques also to calculate the curl. Even otherwise also we can do. Then the flow is irrotation. That what is this omega y? Rotation component about the y axis, that is dou u by dou z, all are partial derivatives, minus dou w by dou x. This is the rotation components. If it is 0, if this is 0, then the flow is irrotational. We can easily say that u is 3z, here u is 3z, right? Here look at this, u is 3z. This is u. This is w. Now substitute here. What is dou u by dou z? 3. That is 3 minus, what is dou w by dou x there? 3 minus c is equal to 0, implies c is equal to 3. This is one method, there is another method. Actually a 3-dimensional fluid flow will be called as irrotational only if all the 3 rotation components omega x, omega y and omega z become 0. Omega x, omega y, omega z are the rotation components of the fluid about x axis, y axis and z axis respectively. Because here the flow is 2-dimensional in xz plane, if the rotation component of the fluid element about the y axis is 0, I can declare that the flow as irrotational. Supposing if the flow is xy plane, say for example, if the flow is xy plane, then if the rotation component of the fluid about the z axis is 0, if the flow is 2-dimensional and in the xy plane, if the omega z is 0, then I can say that the flow is irrotational. So this is alternate way of doing the problems via rotation components. Actually another thing is also there, del square phi is equal to 0 for irrotational. For this is called as the Laplace equation. This is also known as the Laplace equation, where phi is, what is phi? This is a velocity potential function. This velocity potential function, this will exist only for the irrotational flows. This velocity potential phi exists only for the irrotational flows. That is why irrotational flows are also called as the potential flows. All these points are very important in the fluid kinematics. I said in that video given 1 month back, there will be definitely 1 or 2 questions in the kinematics. Yes, given. Answer is 3 for this. Now, 2 tanks have holes at the bottom here. In one tank there is water, in other tank oil. Height of the both is same. The same diameter, hole's diameter is also same. Then the relation between V1 and V2. If you write the Bernoulli's equation between, generally whenever you write the Bernoulli's equation, I already said, either one location or both the locations are open to the atmosphere. If you just write the Bernoulli's equation between this and this velocity V, supposing there is a tank, there is a hole here, there is a hole here. If this h is the height, this velocity will be given by root 2 GH. This formula is also called as the Torricelli's formula also they call. This formula is famously known as Torricelli's formula. If you write the Bernoulli's equation between this and this, here what is the pressure head? 0. Here what is the pressure head? 0. Why? Because both are exposed to the atmosphere. So here the atmospheric pressure, here the atmospheric pressure. Therefore 0 pressure head, gauge pressure head. And here elevation is 0, here elevation is h. What is the velocity here? 0, because it is a free surface. Because it is a free surface, large free surface, here the velocity head is 0. Here the what is the velocity head? V square by 2g. So by writing the Bernoulli's equation between this point and this point, we can calculate the velocity as root 2 GH. So that means the velocity V1 will be equal to the velocity V2. As this will be applicable under certain conditions, certain assumptions. What are the assumptions? If there is no loss of head. If there is no loss of head, according to the Bernoulli's equation, from Bernoulli's equation, if there is no loss of head, the total head at this location and at this location will be the same. The total head here and the total head here will be the same. Based on that V is equal to root 2 GH is there if there is no loss of head. Actually, some students would ask me, sir, this is oil, this is water. Generally, when oil is there, you would expect this velocity would be lesser as compared to this. Yes, that may be correct if you consider the loss of head. If the oil has got definitely viscous fluid, so there may be, you may expect a more loss of head in case of oil as compared to the water. So this V1 is equal to V2. I could write assuming no loss of head from Bernoulli's equation. Assuming no loss of head or no loss of energy. Okay. If you write the Bernoulli's equation here, what is the pressure? Atmosphere. What is the pressure here? Atmosphere. What is the elevation? H. Here what is the elevation? 0. What is the velocity here? 0. Here the velocity is 0. Why velocity is 0? Because it is a large free surface. Here the velocity is a V1. So if you equate the total head here and total head here, what is the total head formula? Total head from Bernoulli's equation is P by W plus V square by 2G plus Z. Z is the elevation. If you equate total head here and here, you will get that velocity as a root 2 GH, and that is velocity V1 is equal to the velocity V2. Okay. So that is one. If you consider the loss of head, yes, they may not be equal. That assumption also is there. Select the correct option. Yes, this question is a little bit confusing and slightly tougher also. For fully developed pipe flow. First of all, what do you mean by fully developed flow? What is meant by hydrodynamically fully developed flow? Actually, fully developed flow means in our mechanical engineering, there are two different aspects may come. Hydrodynamically fully developed flow, that is different from the thermally fully developed flow, which we come across only in the convection heat transfer. So, forgetting that heat transfer, where we talk about a thermally fully developed flow, hydrodynamically fully developed flow regarding fluid mechanics means the velocity profile whatever we have, that won't change in the direction of the flow. If this is a x, this whatever the velocity profile once established, that will be there at every cross section. That this u is a function of r. This r is the radial coordinate, and u is the velocity at any radius. U is the velocity at any radius. U is a function of r, right? That velocity profile would not change. U is a function of r. This function would not change in the direction of the flow. So that is the meaning of the hydrodynamically fully developed flow, right? And under such cases, compressibility becomes important when Mach number is less than 0.3. Wrong actually. That statement itself is wrong. The compressibility effects of the fluid will come into picture only when the Mach number becomes more than 0.3. Okay. Compressibility effects, the density changes effects of the fluid will come into picture only when the Mach number of the flow becomes greater than 0.3. So this statement itself is wrong. Okay. or if the density changes of the fluid are greater than 5%, then only we consider the compressibility effects. Otherwise, we do not consider the compressibility effects, and we treat the flow as incompressible as long as the Mach number of the flow is less than the 0.3. What is Mach number? Velocity of the fluid divided by velocity of the sound, velocity of the sonic wave, sound wave in the fluid at local conditions. That is called as the Mach number. Okay. So, Mach number deals with the compressibility effects. Actually, that statement itself is wrong. Only when the Mach number goes beyond 0.3, then the compressibility effects come into picture. So, statement itself is wrong. And in laminar flow, friction factor decreases. Second question, for the same maximum velocity, average velocity of turbulent flow is larger than that of the laminar flow. Yes, this statement is correct. Because for fully developed flow, if we just look at the laminar flow, what is the velocity profile in laminar flow? Axisymmetric parabola. This is the axisymmetric parabolic velocity distribution. Axisymmetric parabolic velocity distribution in laminar flow. That means as long as the Reynolds number is less than 2000. This is the laminar flow, also known as the viscous flow. We know that Reynolds number should be less than the 2000. In turbulent flow, it is not it is not parabolic. Rather, it is only central part will be flatter. You see the flatter velocity distribution at the core part. Only you see the viscous effect significant only at the pipe boundary. What is this velocity distribution? It is a logarithmic. This velocity distribution is logarithmic. One is parabolic, other is logarithmic velocity distribution with respect to the radius. That means u is a function of log r, where r is the distance measured from the axis. This is the radial coordinate. Here it is the axisymmetric parabola with maximum velocity at the axis and zero velocity at the pipe boundary. So, as asked, for the same maximum velocity, the average velocity of the turbulent flow is larger than the velocity of the laminar flow. Yes, correct. Because this being a flatter, you see that this is being a flatter velocity distribution, for the same maximum velocity, almost all the central core layers would be having more or less same velocity. But here you see, you will see the maximum velocity only at the axis. Only at the axis you see the maximum velocity, which is incidentally exactly double the average velocity in laminar flow. This maximum velocity which you see at the axis is double the average velocity at that cross section. But therefore, the average velocity in that case would be more than this, because here almost most of the layers would have this maximum velocity. Here only central layer will have maximum velocity, other layers they will have much lesser velocities as you go towards the pipe boundary. So, definitely B is the correct. Friction factor is independent of the surface roughness. Yes, that is a MSQ question. That is also correct. In laminar flow, friction factor is independent of the surface roughness, depends only on the Reynolds number. In turbulent flow, it depends. In turbulent flow, friction factor is not only a function of the Reynolds number, but also on the relative roughness of the pipe. This is called as the roughness, relative roughness of the pipe. This is also called as the Darcy's friction factor or Darcy's friction factor. In a laminar flow, friction factor decreases with the decrease in Reynolds number. Wrong. This statement is wrong. Why wrong? You see that as the Reynolds number decreases, friction factor will increase. If you see this formula, okay. In laminar flow, what is that F called? Darcy's friction factor. So, two statements are correct, B and C. D is wrong, A is wrong. The main difference between the laminar flow and turbulent flow is, in laminar flow, friction factor depends only on the Reynolds number, whereas in turbulent flow, friction factor not only depends on the friction factor not only depends on the Reynolds number, but also on the relative roughness. Rough pipes will have more friction factor as compared to the smooth pipes in turbulent flow, but not so in laminar flow. In laminar flow, roughness has no role on the deciding the friction factor. Two statements are correct. Yes, this is again a question on FM. This is slightly a numerical generally problem. You should be given definitely for the 2 marks. It's a Pitot tube. Problem is a static Pitot tube. Okay. So in Pitot tube, the velocity, Pitot tube is meant for calculating the velocity, square root of 2gh, where this h is given by x into Sm by s minus 1. Here the x is given as 30 mm, you have to convert into the meters. Sm is the ratio of the specific gravities between the manometric fluid and the flowing fluid. Wind tunnel which has got the velocity of air, you see the density of the air is 1.23. It is a wind tunnel, and density of water is, density of the water given, Pitot measure the velocity of air flowing, density of water given, specific gravity of the manometric fluid is given. Manometric, that is mercury. Specific gravity of the manometric fluid is given. This level difference, right? This is the mercury. So manometric, that is rho of the mercury divided by rho of the air. Rho of the mercury will be 13.6 into 10 cube divided by 1.23, that is the density of the air. You have to substitute that one here. X is given. X is the difference in manometric liquid columns in the left limb and right limb, that is given as 30 mm. The ratio of the specific gravity is, what is the flowing fluid? Flowing fluid is air. Flowing fluid is air, not the water. Okay, density of the manometric fluid is 13.6 into 10 cube. Density of the air is 1.23. You substitute that one. Ratio of the specific gravities is the ratio of the densities. You get the h there, put it there. CV you can take it as the 1. The coefficient of velocity you may take it as 1. Nothing is given there, and we can calculate the velocity of the here, this velocity of the air entering the Pitot tube. You can calculate that velocity is happening to be 81.46. Answer is 81.46 meters per second. This is a standard formula for calculating the velocity by using the Pitot tube, static Pitot tube. The level difference between the left limb and right limb is 30 mm. I have converted into the meters there. Ratio of the specific gravities is ratio of the densities. Then this is already done, that C is equal to 3. Yeah, this here comes the heat transfer. Definitely this problem is a tough problem. 1 week ago only I discussed here. I have released one video just 8 days back to look into the last week last week preparation for the heat transfer. I released one video in that this problem has clearly explained. And there is a cylindrical shaped container. This is 1, bottom circular, top circular is 2, and the side cylindrical surface is numbered as 3. While doing the radiation problems, which surface has got which number, what is the shape of that one should have a clear idea. Then only we can do the problem. Now all are black surfaces, 1, 2, 3 are black surfaces. Yes, very good. Then when it is a black surface has no surface resistance. Find the heat transfer from bottom to the curved surface. That means we require, what we require now, Q 1, 2, 3 net. This should be obtained. Net heat transfer between the bottom surface and the curved surface 3. So whenever there are 2 surfaces or 3 surfaces or 4 surfaces, I already said, to calculate the net radiation heat transfer between any 2 surfaces, use the radiation network method. Very useful technique. Now I am going to draw the radiation network technique. Radiation network method. What is this method says? on every surface keep one surface resistance. Between any two surfaces which are exchanging heat by radiation, keep one space resistance. On every surface put one surface resistance. Between any two surfaces keep one space resistance. What is the formula for the surface resistance? 1 minus epsilon by epsilon into A. What is the formula for the space resistance? 1 upon A1 F12 or A2 F23, product of area and the shape factor. The reciprocal of that is the space resistance. Every surface will have a surface resistance. First I draw the radiation network method for 3 bodies, for 3 body enclosure. Three surface enclosure or three surface enclosure so you can see. There are 3 surfaces here in the enclosure, right? 1, 2, 3. This is a surface resistance of 1. This is a surface resistance of 2. This is a surface resistance of 3. Yeah, this is the complete radiation network. This terminal will be EB1, J1. What are the terminals for the surface resistance? EB and J. 1 minus epsilon 1 by epsilon 1 A1. This is EB2. 1 minus epsilon 2 by epsilon 2 A2. This is the surface resistance of 2. This is J2. This is EB3. This terminal is. This is the surface resistance of the 3. Now between any 2 surfaces there will be a space resistance. This is 1 upon A1 F12. This is 1 upon A1 F13. This is 1 upon A2 F23. If you want to calculate the net radiation heat transfer between any 2 surfaces, say in this case I want the net radiation heat transfer between 1 and 3. That can be calculated by calculating the current passing through the space resistance existing between 1 and 3. If you want to calculate the net radiation heat transfer between 1 and 3, just try to calculate what is the heat current passing through the space resistance existing between 1 and 3. Where is the space resistance existing between 1 and 3? This is the space resistance. These 3 are surface resistances. These 3 are space resistance. Space resistance will always exist between any 2 surfaces which are exchanging heat by radiation. The space resistance between 1 and 3 is this. So this current I require, this current. Luckily, fortunately, all surfaces are black. When all surfaces are black, this resistance becomes 0, because for black body emissivity is 1, emissivity of the black body is 1. So this is 0, this is also 0, all are black, this also 0. All 3 surface resistances vanished, disappeared, because all the 3 surfaces are black. No, their emissivity is 1. So these they were no. So final now the radiation network will become, when this resistance becomes 0, EB will jump here. EB will become equal to the J. So now this I'll redraw the network once again after making them 0. This is the only a tough problem, lengthy problem, not a tough problem, rather lengthy problem given in this paper. Now this becomes EB1, because J1 will become equal to the EB1. This is EB2, which is obviously equal to the J2. This is EB3, which is equal to the J3. Okay, which current I require? I require this current. Which has got more temperature? Yes, this current I require, because this temperature is more, T1 is more. Therefore, current goes this way. So EB1 is sigma T1 power 4, EB3 is sigma T3 to the power of 4. This resistance is 1 upon A1 F13, because this we require the net heat transfer between 1 and 3. Therefore, this is the space range. This current I require. This current is Q net 1 to 3. Okay. I know T1, I know T3 because temperatures are given. Sigma I know, Stefan-Boltzmann constant I know, 5.67 into 10 power minus 8. Only problem is what is F13. A1 already I know. A1 is pi by 4 d square, diameters are there. Then what is F13? Now to get F13 I use the summation rule because it is a closed enclosure. F11 plus F12 plus F13 is equal to 1, right? F11 is 0. Why F11 is 0? Since it is a flat surface. This rule is called as, what is this rule called? Summation rule among the shape factors. Important rule. F13 I require, that is 1 minus F12. F12 is given 1 minus 0.2, that is 0.8. F13 is 0.8. I know F13, I know area also. What is area A1? Pi by 4 d square. D is given. Therefore, Q123 net radiation heat transfer between 1 and 3 will be, that current I require, EB1 minus EB3 divided by 1 upon A1 F13. What is EB1? Sigma T1 power 4 minus T to the power of 4 divided by 1 upon A1. A1 will be pi by 4 d square. D is given. What is the D there? 5 meters there. But actually dimensions I am not sure exactly because it is a memory based. All these questions were taken from the students' feedback by asking them, inquiring them, because you don't get the paper, right? Pi by 4 d square into what is F13 into 0.8. D is given 5 meters, you can keep, you will get the answer for the net radiation heat transfer. Answer will be 309.14 kilowatts. Sigma, we should remember the Stefan-Boltzmann constant, 5.67 into 10 power minus 8 watt per meter square Kelvin to the power of 4. Here you obviously you get the answer in watts only, but he has asked the answer in kilowatts. Okay, that is the problem with GATE. What you get the answer may be having different units as compared to the units he has asked. So you will get the answer in watts. By dividing with 1000, you will get the answer in kilowatts. Answer is this, Q123. Actually, some students are in Q2 to 3 is asked. So that supposing if Q2 to 3 is asked, what is that you have to calculate? Q2 to 3 will be this one, this current. This current will be Q2 to 3. This current will be Q1 to 2. Anything can be calculated, this current. Only thing is we require the potential difference and the resistance value, simple network problem, okay. And if it is a Q2 to 3, answer will be 4453. If it is a Q2 to 3, 4453. Because some students are telling it is Q2 to 3 is asked. But what are the problem? But whatever, if you are able to calculate Q1 to 3, you can calculate Q2 to 3 also, because you know this temperature. T2 is known. This is T2 temperature, right? So this is how we have to make use of the radiation network method for any number of surfaces. You can use this technique for 2 surfaces, 3 surfaces, or maybe even 4 surfaces also. Okay. So all the surface resistances have become 0 because all are black, and space resistance will exist between any 2 surfaces given by 1 upon A1 F12 here, or 1 upon A1 F13 here, 1 upon A2 F23. Sometimes you may, if the shape factors are not there, you can write 1 by A13 F13 or 1 by A3 F31 also you can write based upon the reciprocity relation. Based on the data given, you can write this as 1 upon A3 F31, no problem, because reciprocity relation is always there in the shape factor numericals. So this is sigma T1 power 4, sigma T1 to the power 4 is EB1. So every value we know, we can calculate the Q1 to 3, or for that matter any current we can calculate, this current or this current or this current. How do you decide the direction of the current? Based upon the potential value. EB1, T1 is greater than the T3, that is why this is the way current goes. T2 is greater than, sorry, this current will be leftwards. Q122 will be leftwards. Why? How do you know? Because EB2 is more than the EB1, because T2 is greater than the T1. This current Q122 will be leftwards. Okay, right. Yes, this is a very simple question. Air at 30 degrees Celsius is surrounding air. An ice cube at minus 7 degrees Celsius exposed to air with gravity. Gravity effects are there. What will be the air direction? This is an cold spherical. This is the air at 30 degrees Celsius. Sufficient temperature difference is there, right? So it is a free convection. Heat transfer happens. So the air surrounding this will lose the heat by free convection to this. So when air loses heat, pressure is constant, the temperature of the air decreases. When the temperature of the air decreases, immediately the density of the air will increase because pressure is a constant. All our heat transfer processes are isobaric. So as the density decreases, air becomes lighter. Air becomes heavier. As the density increases, as rho increases, air becomes heavier. Air becomes heavier. When air becomes heavier, immediately buoyancy effects come into picture, due to which you will have the flow like this. This is the pattern of the flow. This is the pattern of the airflow. So as the air gets displaced like this, so there is some partial vacuum gets created. Immediately air keeps coming from the top to fill that. So air keeps coming from the top and gets displaced like this. This is the direction of the flow. Downward, answer will be downward. Supposing if it is a hot sphere, say for example, instead of a cold sphere, it is a hot sphere surrounding air, atmospheric air. Then the flow pattern will be like this. These are all the free convection currents where the buoyancy forces will play a crucial role. They are all free convection currents or natural convection currents set up by buoyancy forces. Buoyancy forces are the main driving forces in free convection heat transfer. Buoyancy forces are the main driving forces. These buoyancy forces will come into picture only because of the density changes of the fluid whenever there is a heat transfer. Actually, these buoyancy forces will be there in a static fluid also when if there is a temperature difference is existing. Supposing in a tank there is a water is there. In a tank, there are temperature gradients are existing. You notice that always the hot water will get accumulated on the top and the cold water will sink down. Supposing in a lengthy tank is there, there are temperature differences are there. Hot water will be at the top. If you go to the bottom, cold water will be at the bottom because cold water is heavier than the hot water that sinks down, okay, because of the buoyancy forces. Lighter fluid will always move up, heavier fluid will always sink down, but ice floats on the water. Ice is a different because water has got anomalous expansion. Ice is lighter than water. Ice floats on the water, though it is cooler. The water has got maximum density at 4 degrees Celsius because of the anomalous expansion of water. Okay, so answer will be B. Now this problem is somewhat ambiguous problem. Heat is incident on the plate 2500 watts. 85% of the heat is absorbed by the plate of 500 mm radius, while 65% absorbed by the plate of 3 mm radius. Heat density absorbed by the shaded area. This is the shaded area. Question is somewhat ambiguity. Actually here 2500 is watts is falling. When 2500 is watts is falling, 85% of heat, that falling heat is absorbed. When 85% of heat is absorbed, only the remaining 15% of that will penetrate that, okay, will go through that, okay. Only 15% of that will go through that, and out of that 65% will be absorbed by the inner plate. So the balance must be absorbed by this shaded area. My logic here is, this is the incident area, incident energy. This is the incident heat, incident radiation. Out of which 85% is absorbed by the plate. This plate is absorbing 85% of that. So what would happen to the remaining 15%? That is expected to the penetrate through this, assuming that nothing is getting reflected. Okay, assuming that nothing is reflected, only 15% of that. Out of that 15%, 65% is absorbed by this inner sphere, and the balance will be absorbed by this particular shaded area. So my energy balance goes like so. Out of 2500 watt of heat incident, 85% absorbed by outer sphere, outer plate, outer spherical plate, outer plate. That is only 15% of 2500 will penetrate through plate, out of which 65% is absorbed by inner spherical plate. Got it? 85% is absorbed, remaining 15% will penetrate, assuming that nothing is reflected back. Out of that 15% of the energy penetrating, 65% is taken by this. The balance will be going to the shaded area. Therefore, the radiation energy absorbed by shaded area will be 0.15 into 2500, that is penetrated, okay, minus this is penetrating, minus 0.65 of 0.15 into 2500, because 65% of that is absorbed by this. Out of the, this is energy penetrating, out of this 65% is absorbed by inner one. The balance must be going to the shaded area, so many watt. But he has asked the heat density. Therefore, heat density absorbed by shaded area is equal to 0.15 into 2500 minus 0.65 into 0.15 into 2500 divided by this area. What is this area? Pi, what is our radius square? 5 square minus 3 square. This energy absorbed by this area, that is the energy density. So many watt per mm square. Actually, this problem, because it is obtained from the students by asking them, the data seems to be, all these solutions are given based on the data what we received from the students based on their memory. So there may be some ambiguity also question is there, but with all my knowledge I am able to do this. Actually, there is some energy incident. So this is absorbing some energy. Assuming nothing is reflecting, all that balance will get transmitted. Out of that transmitted, only 65% is absorbed by this. The remaining 35% of that energy penetrated is taken by this shaded area. That is how the energy balance goes. Okay. So, heat density means what is the energy absorbed by the shaded area divided by that area. What is that shaded area? Pi r square minus pi r square of the 3. So, pi square minus 3 square. So many watt per mm square is the heat density absorbed by this shaded area. It's a slightly complicated problem given in heat transfer subject. Yes, this is the problem which I asked you, specifically asked you just 8 days ago to look into that. Look at the video I had given exactly 9 days ago. I mentioned you 8 or 9 days ago that to look into the this particular specific area in forced convection heat transfer. It is a forced convection heat transfer in internal flow. What assuming that the flow is taking place by water with mass flow rate of the water given. What is the mass flow rate of the water? 0.01 kg per second. Okay, and it is a constant heat flux. Constant heat flux conditions, how would you achieve? By electric power coil, by winding the electric power coil. There are two different situations we see in forced convection heat transfer in flow through pipes and ducts. Two different situations we may arise. One is constant heat flux, which means at every location, Q double dash I am showing, Q, this is the usual symbol for the flux. At every location the flux is same. Q double dot is not a function of x. X is the flow direction. Okay, that is another situation is constant pipe wall temperature conditions. At every location the temperature of the pipe wall remains same. Temperature of the pipe wall is not a function of x. That is a constant wall temperature conditions. Any condition may ask, but more prominently this constant heat flux conditions will ask. They have been asking in gate 22, 23, last year also he has asked 24. For the last 3-4 years this particular constant heat flux conditions were repeatedly being asked. Not that next time or next year also they will ask, but generally last 2 to 3 years this constant heat flux conditions repeatedly asking. Okay. Now what we have to obtain is what is the length? Very simple question, not at all difficult. What is that? You have to write the energy balance. What is the energy balance says? Total heat transfer rate, this is the energy balance. Total heat transfer rate between entire pipe and fluid should be equal to the rate of enthalpy change, of water, assuming that it is water, from inlet to exit. This is the energy balance we have to write for any flow through pipes, need not be constant heat flux. And even this equation is valid for even for the constant wall temperature conditions also. The total heat transfer rate between entire pipe and the fluid is same equation I mentioned in my earlier video given 8 days ago. What is the total heat transfer rate? Heat flux is given into total heat transfer area, that is pi dl. Flux means what? Heat transfer rate per unit area. What is the area of heat transfer? Pi d into length. Okay, it should be equal to the mass flow rate of the water into Cp of the water, the change in bulk mean temperature of the fluid. Delta Tb means change in bulk mean temperature from inlet to the exit. He has given the bulk mean temperature of the fluid at inlet is Tb inlet is 293 Kelvin. Look at the temperatures units. Tb exit, bulk mean temperature at exit, it will be 353. So substituting the values there, what is the heat flux? 2000 into diameter is given as, diameter is mentioned as 60 mm. 60 divided by 1000 into length is mass flow rate is given, but Cp you have to be extra careful, 4186. Don't keep it in kilojoules. Cp should always be kept in joules because left hand side in watts. Tb exit is 353 minus 293. You will get the length. Simple question only, not at all difficult. Just energy balance, from the energy balance equation we get everything. Length we got it as 6.65. This is the length of the pipe. Heat transfer area is pi d perimeter into length. Heat transfer area into flux will give the total heat transfer rate, from which we got the length. Total heat transfer rate between entire pipe and the fluid should be equal to the rate of enthalpy change of water from inlet to exit, given by this formula. Keep the Cp in joules, because left hand side is in watts. This is in watts. So Cp I have kept in joule per kg Kelvin. That precaution we have to take. It's easy question and important question also in heat transfer. Yeah, going to this applied thermodynamics. When you come to the applied thermodynamics, 3 subjects generally we cover: power plant engineering, refrigeration, air conditioning, and IC engines, internal combustion engines, combinedly as kept as applied thermodynamics. This is the question on the regularly they will ask. Generally applied thermodynamics means you will definitely have a one question on the Rankine cycle and its modification, regeneration, or a reheating, or sometimes regarding the steam turbine, modified Rankine cycle, etc., etc. All the questions will revolve around that Rankine cycle and its modifications. Okay, that is a regularly expected question in GATE, particularly from this chapter. First I draw the Rankine cycle. Everything should be understood only from that temperature entropy diagram of the Rankine cycle, and he has given one that isoentropic efficiency has given. That means the expansion of the steam in the turbine is not truly isoentropic, it is a irreversible adiabatic. So this is isoentropic process. If there is irreversibility during expansion, the actual process goes like this. Okay. Mass flow rate has been given, isoentropic efficiency, calculate the turbine power output. This is actual. This is vertical going is isoentropic. This yellow color one is an actual expansion, actual work output. This is boiler pressure, this is the condenser pressure. Okay. So if you want, what you require is actual work, means first I calculate the isoentropic work. This work I calculate, isoentropic work. Once you know isoentropic work, this isoentropic efficiency, how do you define? Actual work output, divided by isoentropic work. Actual work divided by isoentropic work. That means if you can get the isoentropic work output, you can easily get the actual work output. Therefore, to get the isoentropic work output, I need this dryness fraction, x2 dash I should require. For that, I will equate S1 is equal to S2 dash. S1 has been given 6.5. What is S2 dash? SF plus x2 dash into SFG at condenser pressure. You have been given SF, SG, they are at condenser pressure, all these values are given. Substitute here, he has given the SF. What is that SFG? SFG is nothing but SG minus SF. SFG is nothing but SG minus SF from thermodynamic property data, properties of pure substances. I know SF, I know SG, substitute there, you get the x2 dash, dryness fraction here at this location. X2 dash we got as 0.803 or so. 0.83. X2 dash I got it as the 0.83 here, from which I can calculate the H2 dash. Here I am calculating. Next step I am writing that at the top, because there is no place there. H2 dash will be HF plus X2 dash into HFG. HFG is not given. I could write HG minus HF at condenser pressure. All the data were given. That is, HF is how much at condenser pressure? HF 341 plus 0.83 into Hg minus HF 2645 minus 341. So this is the H2 dash. Yes, finally I got the H2 dash here. once I get the H2 dash, I can get the actual work. So I'll get the here. I'm writing here next step. All I'm trying to put in one page. W actual will be isoentropic efficiency of the turbine, which is given as 0.9 into H1 minus H2 dash, because this is isoentropic work. Into isoentropic efficiency will be the actual work. Then power output will be turbine power output will be mass flow rate of the steam, which is given, into W actual. Everything I will put it in kilojoules. Everything I am putting in kilojoules. Therefore, the power also will get in kilowatts. But he has asked the answer in megawatts. That is a problem with gate. What you get the units in the answer may be different from what is asked. So we have to convert that kilowatts into the, you will obviously you will get the answer in kilowatts here. Now this. Now divide with 1000 to get into the megawatts, because he has asked in megawatts. I give the answer. Power output will be, I got the answer as 99.961. This is the final answer. 99.961 megawatt. After dividing this kilowatt into the 1000, understand, first I have equated the entropies. S1 is equal to S2 dash. From that equation I got the dryness fraction as 0.83. Once I get the dryness fraction after isoentropic, this expansion is isoentropic expansion. That is why I have equated the entropies. I got the, after getting the dryness fraction there, I got the enthalpy there. So once I get the enthalpy, this enthalpy difference is the isoentropic work. Isoentropic work I have multiplied with the isoentropic efficiency to get the actual work. That actual work I have multiplied with the mass flow rate of the steam to get the power output. I get the answer in kilowatts, but that has been divided into 1000 to get the answer in megawatts. Yes, this is a typical regular problem where you have to understand the meaning of the isoentropic efficiency. So answer has been obtained as 99.961. Okay. The only precaution is we have to carefully take the property data. It is clearly given all this property data is corresponding to the condenser pressure. That data we require more. H1 anyhow given, that is the supply steam at the inlet of the turbine. H33.34 H1 has been given. H1 minus H2 dash is the isoentropic work into isoentropic efficiency, because 10% losses is there due to friction. During the expansion of the steam in the turbine, due to friction there are 10% losses. So that is why isoentropic efficiency is 0.9. It's a direct question. Such a simpler questions I never seen in the gate. Actually, very rarely we see such kind of a any fellow who has once seen the psychrometric chart, you must have used sometime in the semester. What is y-axis is asking? That is specific humidity in kg of water vapor per kg of dry air. This is the units. So what is there in the W? W is called as the specific humidity. It has another name also. Specific humidity or humidity ratio. Specific humidity or another name is humidity ratio. Both mean the same. Some books will use the humidity ratio, but more commonly it is known as specific humidity, W, small w. Okay. Answer is specific humidity. These are the relative humidity lines. Relative humidity lines will be like this. These are all the relative humidity lines. Here the relative humidity is phi. This is called saturation curve. Here the phi is 80%, phi here, phi is, these are all the RH lines. Phi is the RH. Wet bulb, for their information, wet bulb temperature lines like this. These are all the WBT lines. Straight lines, inclined lines, constant WBT lines. DPT lines you don't see, but you have to touch the saturation curve and read the DPT. These are the WBT lines which are parallel to the constant enthalpy lines. These curves are RH curves. This is the actual answer is specific humidity. Is not mentioned The other axis means vertical axis. What is there? W. Final answer is W, called specific humidity. Its units are kg of water vapor per kg of dry air. Amount of water vapor carried by 1 kg of dry air in a mixture of dry air and water vapor or the atmospheric air is called as the specific humidity, also known as humidity ratio. Approximately there will be around 3 grams to 28 grams of water vapor present along with 1 kg of dry air. Usually in the atmosphere, the lowest specific humidity, usually in the normal climatic situation, lowest at any location will be around 2 to 3 grams, highest will be around 27 grams of water vapor along with 1 kg of dry air. That is called W. If that is also even more simple question, air standard thermal efficiency. Air standard thermal efficiency is 1 minus 1 by R to the power of gamma minus 1, it is given as 0.5. We know that for air standard cycles, gamma is, because in the name itself it is there, air standard auto means working fluid is air. So substitute there, you will get the compression ratio R. Petrol engine, right? Petrol engine means compression ratios will be around 5 to 9, 5 to 8. Here the compression ratios is 5.65. It is meant for the SI engine or the petrol engine or the gas engine. The compression ratio here is straight question, very simple. All the power plant questions are just we can be answered in 30 seconds maximum, each question, if you know subject reasonably well. Here that stream is over. That, and of course one more question is there. I forgot to do that. One more question I will do that. The Pelton wheel. I have not typed it. There is a question on the Pelton wheel. And it was not typed here, but I still remember. Some students told me there is a Pelton wheel. What is being asked is, if the Pelton wheel is operating for the maximum hydraulic efficiency condition, generally in the Pelton wheel is a pure impulse turbine, right? It is a pure impulse hydraulic turbine. So you will have the jet coming from the nozzle. The jet coming from the nozzle is V1. If this bucket velocity, tangential speed of the bucket is U, this is the jet, V1 is jet velocity. U is the tangential speed of bucket, tangential speed of wheel, tangential speed of Pelton wheel, given by pi d n by 60, where d is the diameter, mean diameter up to the center of the buckets, diameter of the Pelton wheel. N is the RPM. N is the RPM. So for maximum hydraulic efficiency, condition is, this is the question that most likely being asked. For maximum hydraulic efficiency of Pelton wheel, for maximum hydraulic efficiency of the Pelton wheel, condition is U by V1 should be 0.5. When the bucket speed is exactly half of the jet velocity, then you will get the maximum hydraulic efficiency. The hydraulic efficiency of the Pelton wheel is maximum when the bucket speed is half of the jet velocity, which is coming from the nozzle. This is the nozzle, right? And that means you know V1 has been given, U is equal to half of V1, and equate that to the pi d n by 60, and a diameter has been given. You need to calculate RPM of wheel. I think somebody said answer will be around 12,000 RPM, 1200 RPM. So this is the answer. So question is very simple. These questions are very, very simpler questions. Actually earlier also Pelton wheel was asked long back, around 4-5 years back, but that is not this easy. There we need to calculate some tangential force or the torque. After many years hydraulic machinery is asked. After I guess after 4 years we are seeing the hydraulic machinery. But that question is also so simple. So overall paper is pretty easy. Now going to that second domain called as the strength of materials. Strength of materials is asked the 5 questions. All the questions are very simple. 1 Newton meter per meter uniformly distributed bending moment over a span of one beam, 1 meter length beam, simply supported beam, hinged at A and roller at B. It is a simply supported beam. Bending moment at midpoint. Those who have done this such kind of problems many times, those who are well versed with this kind of a problems, those who are prepared well for the gate, reasonably well for the gate, directly they can answer, the answer will be 0. Because at no section you will see a bending moment. At every section, considered from the either from the hinged end or the roller end, at every section bending moment will be 0, and the shear force diagram will be a rectangle. Shear force remains constant. This is SFD. We know that bending moment is ds by dx, right? When bending moment is constant, bending moment do not change, bending moment is 0. The rate of change of shear force is the bending moment. When shear force is constant, bending moment is 0 at every location. So, bending moment diagram is a straight line at the 0 scale. At every spot, bending moment is 0. Without doing also we can do, but with doing we will do it. We will do the calculation there. First we will calculate the reactions. It is a roller reaction, definitely it will be vertical, and this is a uniform bending moment, uniform bending moment at the rate of 1 Newton meter per meter. Uniform bending moment at all the locations. The two reactions must be opposite to each other. This is, if you take this as A, this as B, this is RA, this is RB. They will be in the opposite directions. That is, first we have to calculate the reactions, right? At the hinged end RA downwards, RB is at the roller end, RB is upwards. Okay, that will be, RA will be, if you calculate based upon the equilibrium, M is, this is the M into L by length, this will be M. So both the reactions will be same. RA is equal to RB, but opposite. RA is equal to RB. Both the reactions are same. RB is equal to RA, right? So if you just consider any section, X from the hinged end, bending moment at any section distant X from A. How to calculate the bending moment? Reaction RA into X minus that rate of loading. You know what is the rate of loading there? M. Rate of bending moment loading will be M into X. So RA is given as, already we have calculated RA is equal to RB is equal to M. Therefore bending moment is 0. At any section bending moment is 0. This is the shear force diagram. So from this also we can see the rate of change of the shear force with respect to X is bending moment. The shear force constant. At every location shear force is constant. That is why it is a rectangle, shear force diagram. Shear force remains constant all along the length of the beam. Therefore bending moment is 0. So answer is, this question is 0. Yes, this is the question I have highlighted just exactly 1 month back. Please look into the strain energy. Mostly questions very repeatedly they were asked so many times. Strain energy, the energy stored inside the elastic member by virtue of the deformation or the strain. Okay, when you compress the spring or elongate the spring, just like energy gets stored inside the spring, in the similar manner, in any elastic member gets deformed, so there will be an energy stored inside that member by virtue of the strain. So this is the stress, this is the strain. We know that the strain energy, this is the fracture point, this is the fracture. Okay, find the strain energy per unit volume, that is strain energy density is asking. And generally a typical mild steel diagram we must have studied in the strength of materials, the very important diagram, the stress versus strain. elastic limit, lower yield point, upper yield point, and then ultimate strength and breaking point. Like this is an elastic limit, you can say, where up to which Hooke's law is valid, or limit of proportionality and elastic limit, both are close by that. And this area up to the elastic limit, this area will indicate modulus of resilience or the proof resilience, this area. Whereas what is asked is find the strain energy per unit volume up to fracture. That means he is asking about the modulus of toughness. That means entire area. If you just look at this, the entire area, the whole area up to the breaking point, this is the breaking point up to or the fracture. The entire area, all this area will be the, all this area will give the strain energy stored per unit volume up to breaking point, fracture up to breaking point or the fracture. This is also called as the modulus of toughness. So that is asked here in this problem. The modulus of toughness is asked. Find the strain energy per unit. That is this area. So strain and modulus of here, modulus of toughness total area under curve, that is half into base 0.01 into 100, this triangle area plus that parallelogram, this trapezium area. What is the trapezium area? Plus half into 100 plus 120 into this gap. This gap will be 0.005, sum will be 1.05 megajoule per meter cube. This is the modulus of toughness. The total energy stored up to the, what is that modulus of toughness means? The total energy stored in the elastic member up to the breaking point or up to the fracture point. That is nothing but the total area. This total area is equal to modulus of toughness. If he has asked up to, if you consider the area up to the elastic limit, that is called as the proof resilience or the modulus of resilience. Here the strain energy stored within the elastic member up to elastic limit is called as the proof resilience or modulus of resilience. But up to the fracture, if you take the area, it is called as the modulus of toughness. Toughness is the property of the any elastic member to store the energy, to absorb the energy rather. Yeah, this is the yield stress. Yield stress in the case of uniaxial loading. In the yield stress in the uniaxial loading is 200 megapascal. Okay. Yield stress in tension in case of the uniaxial loading is 200. Then according to the von Mises theory, very important theory, von Mises theory, or maximum distortion energy theory. Maximum distortion energy theory. What is the yield stress under pure shear? Yield stress under pure shear. This is the yield stress under the uniaxial loading, under the uniaxial tension, under the uniaxial loading tension like this. That is this. You know, this is the meaning of the uniaxial loading tension. then the yield stress will be SYT divided by root 3. This is a straight question. You have to remember the theories of failure, the 5 theories of failure, Truss, von Mises, Rankine, all those theories you have to thoroughly, only 5 theories are there: maximum shear stress theory, maximum shear strain energy theory, maximum shear strain energy theory, all these, and maximum distortion energy theory, all these theories we have to thoroughly understand. One question is 100% come. Whether you do a GATE exam or a IES exam, IES they will come more questions on these theories of failure. Only 5 theories of failure. We have to understand about each theory of failure. But all the theories of failure, interestingly, they will compare the particular case with the uniaxial loading under tension. Everything is linked to the uniaxial loading under tension, all the theories. But each theory will be applicable to a particular kind of a material. For brittle materials, some theories are valid. For ductile materials, for some theories are valid. Okay, so that a particular theory is valid to a particular kind of a material. So you have to learn about the logic behind the theory and to what kind of material the theory is applicable. You have to understand those 5 theories. Please repeat any exam pertaining to the mechanical engineering in the design or the standard materials, they will be definitely asked. Answer is 115.3. Okay. According to my yield stress for the pure shear will be yield stress under the uniaxial loading and uniaxial tensile loading divided by root 3. So this is the straight question based upon the Hooke's law. He has asked it is a 2-dimensional stress element. Poisson's ratio mu is given 1 by m, rather lateral strain by longitudinal strain, it is 0.27. He has asked the strain in z direction. This is x, this is sigma x stress, and this is sigma y. Sigma y is compressive, whereas sigma x is tensile. That is the okay. And he has asked the strain in z direction will be epsilon z, will be stress in z direction divided by Young's modulus minus mu into sigma x by E minus mu into sigma y by E. Just substitute all the values. This is 0 because it is a plane stress. It is a 2-dimensional, no? Since 2D plane stress. So there is no sigma z. There is no stress along the z direction. This is x. This is x. This is y. But there is no stress along the z direction. So mu is given, sigma x given, sigma y being given. Answer will be minus 0.27 into 10 power minus 3. This is the strain in the x, because you know that Poisson's ratio is lateral strain by longitudinal strain. .25 to the 1 by 3 to 1 by 4, but usual elastic materials, common engineering elastic materials, m varies between 3 to 4. So it also is very simple question in strength of materials. Strength of material question somehow actually I don't know, this year is becomes too easy. Generally the some questions will not be that easy. Some questions cannot be that easy. As asked, I don't know, almost all the subjects they have asked pretty easy. If you just observe power plant, nothing there. Some also not any big deal. Actually this is even easy. More circle under hydrostatic pressure. An element subjected to the hydrostatic pressure, according to the Pascal's law, a point at a point in a fluid under rest, the pressure exerted is same in all the directions. That is called as the Blaise Pascal's law. So this has been asked many times. It is a compressive in nature. Hydrostatic pressure is a compressive stress in nature. And the radius of the Mohr circle for a two-dimensional element, radius of the Mohr circle this question I also explained in fluid mechanics. When I was explaining the Pascal's law, when I was look at my videos there, in the fluid mechanics videos, this point I have raised when I was first defining the hydrostatic pressure before defining the Pascal's law. Radius of the Mohr circle is sigma x minus sigma y by 2. That will be sigma x is sigma y, that is 0. That means Mohr circle radius shrinks to a point. So answer is C. This is generally sigma, this is shear normal stress, this is shear stress. So this is the answer is why on the left hand side, because it is this is the state of stress. Compressive in nature, no? That is why for a fluid element at rest there are no shear stresses. A fluid element at rest is not subjected to any shear stresses. A fluid element at rest is not subjected to any shear stresses. Any tangential or shear stresses. Only normal stresses will be there. A fluid element rest is subjected to only the normal stresses, that too of compressive in nature. So this is the answer C. This is the answer for the, if it is a pure shear or a complementary shear, this would have been the Mohr circle. Last year also he has asked the Mohr circle. In my 1 month back I had given the video, no, I specifically mentioned you will not see a gate paper without a Mohr circle and principal stresses, very very important. Just like theories of failure, one question will be guaranteed in the principal stresses, principal strains, and the Mohr, how to construct a Mohr circle, radius of the Mohr circle, etc., angle of obliquity, etc., etc. So all the questions of the SOM are quite easier, very very easy. Now this coming to the engineering mechanics, this is a simple equilibrium. This is at O. Sigma is equation, writing the equation of the equilibrium, net algebraic sum of the moments about O is equal to 0 for static equilibrium. In the engineering mechanics statics, the three equations are valid, you know, sigma fx is 0, sigma m fy is 0, sigma m O is 0. That is, if we take the moments, 50 kg into 5 meters, that is anti-clockwise, should be equal to the W into 8 meters. You will get the weight of the block B, W in kg. Anti-clockwise moments should be equal to the clockwise moments. This is clockwise moments, this is anti-clockwise moment. Moment will be 50 into 5, clockwise moment will be W into 8. This is the good question. Is a truss? Is a truss a plain truss? Where is the, which member is carrying 0 force? If this is 90 degrees, the symbol itself is showing 90, right? So at this joint, for the equilibrium of that joint, this is perpendicular. It cannot have any force component along that direction. So there are only two members which are collinear, which means there is no, it is a 0 force. It is a zero force. There is no force here because at this joint there cannot be any component along these directions. They are collinear. They are collinear, and therefore for the equilibrium of the joint B, the force here must be equal and opposite, and there is no force in the BD. So answer is A. And incidentally, there may be another 0 force member. If you just draw the free body diagram, first in any truss we have to draw the free body diagram. The normal reaction goes like this. At D, normal reaction. It is a 0 force. That means there must be collinear, right? The line of action like this. So that should be balanced by a force exerted in the AD. So these two are collinear, there is no force here, and this is perpendicular to this. This is a perpendicular. That means here also zero force member. Both CD and BD are zero force members. So very simple questions in Truss, but it is not MSQ. CD is not given, therefore answer will be A only. Answer will be A only. Each truss could be given like this. Now I can draw the forces acting. So this is vertical, this should be downwards, it should be upwards. When it is upwards, okay, this should be downwards because it is horizontal. It should be downwards because for the equilibrium of A, this should be downwards. It is like this. So all the forces I have marked here, internal forces. Which member is tension, which member is compression, you can easily decide. So totally there are two zero force members are there, BD and CD. Because this is perpendicular, right? This will balance this. This is already zero force member. That means this cannot have any component in this direction. Therefore only these two forces must balance each other. So this must be a zero force member. It's a very good question. Engineering mechanics. All the questions in the engineering mechanics are also, 3 questions I have asked, all are very easy. It is a question of pure rolling. It is a question of pure rolling. Under pure rolling condition, that this will be moving with a RO. This is this is radius R, omega R O will be, and the velocity at A will be 0. Answer will be D. So answer will be D. Velocity for the A is 0. For the O, it will be, velocity will be omega R. 0 and omega Ri. Answer is D. It is a pure rolling, a disc under pure rolling. So 3 questions of engineering mechanics are quite easier. Now this is a machine design. A lap joint, okay, is a lap joint, a transverse load subjected to a transverse load of 5 kilonewtons. SYS is given 150 kilopascal yield stress, and factor of safety is 3. Find the length of the weld. Plate thickness is 10 mm. Okay, it is a single fillet welded lap joint. What is the length of the weld? Therefore, the applied load is a parallel fillet only. Is a parallel, assuming the parallel fillet weld, applied load P should be less than or equal to the strength of fillet weld. Applied load is 5000 newtons, should be less than or equal to, for a fillet weld, parallel fillet weld, it is the design criteria. Thickness is given, or the leg of the weld is given, into tau permissible. .707 into thickness is given 10. For the parallel fillet weld, equivalent length can be taken as L. The permissible shear stress will be SYS divided by factor of safety. Factor of safety is given as 3. So you will get the length of the weld as 14.14 mm. This is a design criteria with factor of safety. Length should be greater than or equal to 14.14 mm. In helical gears, which one of the following can't be used because it is suitable only for the radial loads? See, this tapered roller bearing can be used for radial as well as axial loading. This also, all the three ball bearings can be used for the radial as well as axial loading. But whereas straight roller bearing, or which is also called as the, can be used only for radial loading. But whereas the helical gears are concerned, helical gears are subjected to both the radial loading and as well as the axial loading. So these three things can be used for the radial and as well as the axial loading, whereas this can be used only for the radial loading. In helical gear, there will be both axial and radial loading. There will be both axial and radial loading. Therefore, that cannot be used. Cylindrical roller bearings or straight roller bearings can be used only for the radial loading. Therefore, answer is A. Answer is A. Whereas other three varieties can be used for both radial loadings and as well as the axial loadings. Helical gears, there will be axial loading and as well as the radial loading. This cannot sustain the axial loading, straight roller bearings. Therefore, it cannot be used in the helical gears. So, answer is A. It is the repeated fatigue stress. It is a variable stress. Repeated fatigue means cyclic variation, 0 to maximum. Any fatigue means fluctuating stress or fluctuating load. So 0 to maximum, there is a fluctuation. Fatigue stress means 0 to sigma maximum, it will be fluctuating. Stress will be fluctuating. Therefore, I calculate mean sigma, that is sigma max plus sigma minimum by 2, but sigma minimum is 0 here, it becomes sigma maximum by 2, and sigma A, that is the average or the stress amplitude, average stress, or which is also called as the stress amplitude. It will be sigma maximum minus sigma minimum by 2, it will be sigma maximum by 2. Now, I would use this Soderberg's equation. Soderberg's equation, that is sigma m by SYT plus sigma A by sigma E should be less than or equal to 1 by n. N is the factor of safety. If we substitute the given values, sigma maximum by 2 into sigma E should be less than or equal to 1 by 2. Therefore, sigma maximum, you will get 0.5 into sigma E, which is equal to the, if the endurance limit is equal to the yield strength. Sigma E is the endurance limit, E for endurance, 0.5 into SYT. So answer will be C. Factor of safety is 2. N is the factor of safety. The 27th question is 0.5 into SE, where SE is the yield strength, sigma is the endurance limit. This sigma E is the endurance limit. Yeah, this is that is how the design questions were answered there. Now coming to the theorem missions. Theorem missions slightly tougher is given. It is a slider crank mechanism. You can say this is a Whitworth quick return crank mechanism. The same principle is used for the Whitworth quick return mechanism also. There is some offset given. Eccentricity is given. Okay. We have to calculate what is the stroke length for this slider crank mechanism. This is a crank. This is a crank length is given. Connecting rod is given. This is a piston. This is a crank length. This is a connecting rod. There is some eccentricity or offset. We have to calculate the what is the stroke length of this mechanism. So when the piston is reciprocating, there are two extreme positions. When the piston is at the two extreme positions, because as it is reciprocating, at the extreme positions, that crank and the connecting rod, they fall in the same line. That is the point you have to understand. At the extreme positions of piston, crank and connecting rod become collinear, fall in same line, That is the point we have to understand. Remaining things are easy. I'll just draw the figure when they are falling in the same line. This is the piston. This is one extreme position. Another extreme position will be when the piston is at the other end. So these two things are this is fitting, this is ON dash. These two are the two extreme. When the piston is at the one extreme position, the crank, this is the crank, this is a crank, this is a connecting rod. Both are falling on the same line. When the piston is at the other end, you can notice this. When the piston is at the other end, this is crank. This is the other thing is the connecting rod. They are collinear, but this dimension, okay, this dimension will become 50 minus 20. Here, this dimension will become 50 plus 30. If you can use the Pythagoras theorem for this right angle triangle, stroke length will be ON minus ON dash. That's it from the geometry. What is ON? ON will be square root of that 80 square minus 10 square. ON dash will be, this is O, no, this is O. This is ON dash will be 50 minus 30. This is the right angle triangle. That is 20 square minus 10 square. If this is a right angle triangle, so ON dash will be, ON minus ON dash will be the stroke length. From the Pythagoras theorem, this square minus this square will be this. So that will be stroke, we got it as the 62.05 mm. So this is an application of the Whitworth quick return mechanism, you can say. There is an eccentricity given. The two extreme positions of the piston I have considered, but when the piston is at the any extreme position, whether that extreme or this extreme, they fall collinear. This crank and connecting rod will fall collinear. This is crank, this is connecting rod. When the piston is at the other end, other extreme position, this is crank, that is the connecting rod. OA is the crank, AB is the connecting rod. This is OA is the crank, AB is the connecting rod. Now this is a minimum number of teeth required on the pinion. This is a velocity ratio being given, from which the gear ratio will be 2. Here the addendum, this is a module, given, this is the addendum. When the addendum and the module are equal, then AP will be, AG will be equal to the 1. Okay. Pressure angle is 15. This is a gear question. Pressure angle is 15 degrees. Gear ratio is 2. From which the T minimum teeth on the gear can be calculated, keeping in mind the safety of the gear. When the gear is safe, pinion is safe, but may not be the other way. When the gear is safe, pinion will be safe. Pinion is safe, gear may not be safe. So for this keeping the safety of the gear, this is the formula for the this one we got it as the 49. So for pinion, T minimum will be, for the gear ratio is there 2, it should be 49 by 2, that is rounded up to the 25 teeth on the pinion. G is there, G is AG is 1, phi is pressure angle, gear ratio is 2. So substitute all the angles, you will get the minimum number of teeth on the gear. Keeping in view of gear safety. So this is a very good question, is vibrations, very good question this is. Natural frequency of vibration, free oscillation, free vibrations. This is the natural frequency. Here it is a beam, a cantilever beam. A cantilever beam is connected to the one side. This is the spring, this is the spring, this is the mass is attached here. Its Young's modulus given, moment of inertia I, okay. L is the length, L is the length, it's not the one, this L is the length. So now what is the, first of all we should know what is the bending stiffness of the beam, okay. So what is the, for cantilever beam, what is the beam deflection? Because this is carrying this load carried is maybe unequally shared by the beam and the spring. This load M is shared maybe unequally by the beam, by the cantilever beam and the spring. So beam deflection will be delta will be mg L cube by 3EI. So bending stiffness of the beam will be square root of the K of the beam divided by M. Should be calculated, bending stiffness should be calculated like this. If K is the bending stiffness by M should be equal to the implies bending stiffness of the beam, which is called K, 3EI by L cube. So here bending stiffness of the beam, K is bending stiffness of the beam is obtained like that. And then this beam and the spring are supposed to be in parallel, because whatever the deflection of the beam, same is the deflection of the spring. The deflection of the beam and the deflection of the spring are exactly equal, which means this beam should be taken as the spring which is connected in parallel to the spring. So we have to consider the whole system as a two parallels carrying both of them M. This is the KE, equivalent bending moment, K of the beam, this is the K of the string. So what is the equivalent bending moment, equivalent stiffness? Because they are connected in parallel, equivalent stiffness will be K of the beam plus spring constant, that is 3EI by L cube plus K. So omega n, natural frequency of the entire system, is the root of K equivalent divided by M, that is square root of 3EI by L cube plus K whole divided by M. You can take the M LCM and get the final answer. So the entire problem lies on two steps. One is getting the bending stiffness of the beam. This is a cantilever beam. And after getting the bending stiffness of the cantilever beam, we should think that that cantilever beam is supposed to be acting as a spring which is connected in parallel to the already existing spring. So the whole system goes like this. This is regarding this spring is equivalent to this beam, cantilever beam, whereas already there is a spring existing. So both of them together are carrying the mass, because the deflection of the beam and the deflection of the spring are exactly equal. That is the logic that they are connected in parallel. Deflection of beam is equal to the deflection of spring. That is why we are assuming them to be connected in parallel. Equivalent stiffness is K of the beam. K of the beam already got it. Beam deflection is that K is the bending stiffness of the beam. That is K of the beam is obtained by root of K of the beam divided by M is equal to root of G by delta, from which bending stiffness of the beam is obtained. So after getting the bending stiffness of the beam, that is connected in parallel with the spring, from which we calculated the equivalent stiffness and then we have calculated the natural frequency omega n. If the damping factor of damping ratio is equal to omega d by omega n, then what is the zeta? Okay. Omega d is the damping frequency of oscillation this omega d is given by square root of 1 minus zeta square divided by omega n divided by omega n into omega n divided by omega n, it will become zeta. That is zeta square zeta, that is 1 minus zeta square is equal to zeta square, then zeta will be 0.707. Manufacturing. In fact, before that, actually there is one more question is being asked actually in the balancing. In the balancing, there is one question is asked. One mark question only. I think 1 mark or 2 mark, I don't remember. A reciprocating mass for the balance, a reciprocating mass like IC engine can be balanced by single mass system. Reciprocating mass can be balanced by two masses can balance. I think both these statements are wrong. And rotating mass single mass can balance. A rotating mass, a rotor can be balanced by two masses on two different planes. On two different planes can balance. This is the answer. This could be the correct option. Totally 5 questions are asked in the theory of machines. This is the regarding the balancing of the rotating and rotary masses, where the a rotating mass could be balanced by two masses rotating in the two different planes can balance this. So that most appropriate answer will be the D. This is the answer. Now coming to the last portion, manufacturing engineering. Manufacturing engineering there. Third stream, ceramics and glass cutting can be done by ultrasonic machining. Now here, this is the casting. This is a question on casting. I was mentioning in my earlier video also. This is regarding the solidification time. If the height of the diameter of a cylinder is equal to the volume of the cube and cylinder is same, h and diameter is equal and volume of the cube and volume of the cylinders are same, then the ratio of the solidification time of the cube and cylinder is, assume K is same. K is the casting constant there. That will be same because materials are same. So first of all, we should know that solidification time of a casting is directly proportional to the square of the volume by area, time of solidification. Okay. Now the time of solidification is just comparing cube divided by time of solidification of the cylinder. V by A whole square of the cube divided by V by A whole square of the cylinder. That is, A is the side of the cube. This D and H are equal. He said D and H are equal is mentioned. That is, this is A by D whole square. Volume of the cube is equal to volume of the cylinder, volume of the pi by 4 D square H. D is equal to H. He has given D is equal to H, implies A by D is equal to pi by 4 into 1 by 3. Now this, if you substitute this here, time of solidification of the cube divided by time of solidification of the cylinder will become pi by 4 into 2 by 3. This is the answer. K is the same for both because the materials are the same. Cylinder material and cube material are the same. So the main contention here is the solidification time of casting is directly proportional to the V by A whole square. Very common. This question was asked in the last year also. The questions on the solidification time of casting are very, very common in GATE. Very common. D is the diameter of the cylinder. H is the height. Where is the, for the cube, A is the side of the cube. A is the side of the cube. So with this contention, that is answer will be pi by 4 to the power of 2 by 3. Now this question is regarding the metal forming. Coefficient of friction, roller diameter, initial thickness, final thickness. Find the maximum draft and given reduction is feasible, not feasible, it should be feasible. Now I'll draw the given figure. So there are two rollers, it is a the rollers are drawing. This is the radius of the roller is 250 mm, diameter is 500. So after drawing the piece, the final thickness has become 27. Initial thickness is 30. Like this is Hello students, welcome back. We have done this problem on the rolling, that because the maximum possible reduction is 3.7 mm, but you are doing only 3 mm, so this rolling is feasible. There is one more question also asking in welding. Actually this is not typed here. The question asked was like this: in automobile industry, if different parts made up different parts made of different materials and of different thicknesses to be welded, which type of welding is suitable? This is the one question asked actually. That answers will be most probable options will be friction welding or laser beam welding. Actually metal inert gas arc welding also will be there, MIG welding, but I can say more appropriate answer is friction welding. So this is also question asked in question regarding the welding. Actually all the 4 parts he has touched: forming, welding, casting. Yes, he didn't leave anything. He has touched everything, and that is how. But he has touched everything, not a tougher level. He didn't go to the deep. Peripherally he has touched all the topics. Then coming to this metrology. This is a metrology. In the metrology, for this question answer will be transition fit. Interference, loose fit, there must be in the transition fit there will be some overlapping, because if you just draw the figure, you will come to know that there is a overlapping for this shaft and the hole. So answer will be transition fit. Again it is a problem on casting. Casting has asked 3 questions, I guess. Yeah. So a cavity, mold cavity of dimensions 200, 200, 200. No compensation is given to the shrinkage. No compensation is given to shrinkage. Volumetric solidification, volumetric shrinkage 8%. So find edge length after solidification. This is the mold. Before this you have made this is a mold or cavity. Volume, this is, you have poured the liquid, molten liquid into that, and volumetric solidification, solid shrinkage is 8% and liquid shrinkage is 7%. Here solidification, liquid to solid solidification, it will be 7%, and the solid shrinkage is 8%. Solid shrinkage is 8%. Then what will be the final side of the casting? Actually is asking, therefore volume after casting, it will be volume of liquid cavity or mold, into 1 minus shrinkage. That is, what is the volume of the mold cavity? Before pouring the liquid metal there, the total volume of the cavity is this much, but it gets shrinkage, once while getting solidified, and after getting solidified there is some more shrinkage. 200 into 7% got shrinkaged during solidification, and after that again 8%, right? 8%, 0.92. So this will be equal to the EOQ, the final side of the cavity, from which A will be obtained as 89.7 mm. This is the mold or cavity volume before pouring liquid, before pouring molten liquid. That is, there is a shrinkage during the solidification, and there is a shrinkage during the after getting solidified. Solid shrinkage and liquid shrinkage. So what is the final size of the casting is asked. A is the final side of cube after getting complete, after getting cast, that is the final side of the cube. This is a liquid metal poured volume. This is mold or cavity volume before pouring the molten liquid. He has asked 3 questions on the casting. Here this is a boundary representation. This is a spelling mistake. Answer is boundary representation. CAD solid models can be constructed by using boundary representation. Here the match the following. Is the additive manufacturing. In this, all these processes are in the powder metallurgy. SLA means stereolithographic. FDM means fused deposition modeling. Laser object manufacturing. Laser energy net shape. LENS means. So these are the matching there for the additive manufacturing. The skim bob is to A to the 2 chills or for the rapid cooling. Inoculations is to control the solidification rate. Insulating material is minimize heat transfer. Insulation, these are the matching. A2 skim bob is to trap impurities. Chills is for the rapid cooling. C is 4, control solidification rate. Insulating material is to minimize heat transfer. This is the matching. This is also the casting equipment as such. Casting accessories rather we can say. Many questions are asked in the casting, in fact. This is the economics of the metal cutting. Very lengthy question he has asked, but I will give the formula there. All the data is given: diameter of the workpiece, length of workpiece, cutting speed, feed, tool life constant, Taylor's tool life. This is V to the power of n is equal to constant. Tool life constant, the tool life exponent, n is tool life exponent, tool change time, labor cost to determine the tool change cost per piece. It's a little bit lengthy problem he has given, but this is the formula. Tool change cost per piece will be Z1 into number of tool failures into tool change time. Z1 is the direct labor cost But unusually problem is given. Generally they will give the orthogonal mechanics of the metal cutting they will usually give, but this is unusually has changed this. 5 is given 5 per minute, rupees 5 per minute. Number of tool failures, number of tool failures. Number of tool failures within machining time. Within machining time is Tm by T, where Tm is the machining time per piece. Machining time per piece, that is length divided by F. F is the feed, N is the RPM of the spindle. N is equal to RPM of spindle. It is given by 1000 V by pi D. D is the diameter of the workpiece, and from which we can get the Tm as 400 divided by 0.2 into 1000 V by pi D. You will get Tm, machining time per piece, as 15.08 minute. T is the tool life, which has been given. No, sorry, it's not given, you have to calculate. From Taylor's tool life equation, you have to calculate this tool life. Vt to the power of n is equal to constant, from which this T can be calculated as 1 by n, 1 by exponent will be given as 0.25, it is 0.81. This is T, I got it as 81. Therefore, number of tool failures Tm by T, it will be 15.0857 divided by 81, you will get 0.1862. And the tool change time given. Tool change time is also given. That is data given, that is 3 minutes. So, by substituting all these things, tool change cost per piece. .1862 into 5 into 3, that is 2.793, rounded up to 3 rupees per piece, by substituting this formula. This is the tool change cost per piece. This is the one we require. This is the formula. Z1 direct labor cost has been given. We have calculated number of tool failures and the tool change time. Number of tool failures will be Tm by T. This is the formula for the Tm. This is the formula for Tm there. Tm is the machining time per piece. L by F into N. Everything is given. You have to just keep on substituting. Number of tool failures should be obtained from the within machining time. This is Tm by T. T is the Taylor's from the Taylor's tool life equation. T is obtained. Tm is obtained from this formula. So, tool change cost per piece will be 3 rupees per piece. Now, finally, lastly, we will have got the industrial engineering. This is the problem, actually 3 problems asked. One is on the demand forecasting. This is on the demand forecasting. One question on the inventory, one question on the CPM PET. In this demand forecasting, period given, demand given, forecast given. First I calculate the error. error EI is equal to demand minus forecast. We have to calculate error there. For example, 425 minus, this is minus 2, like that. This is minus 7, this is 4, we have to calculate like this. This is error EI. After getting that, sigma modulus of EI without bothering the sign, it will be 42. Mean absolute deviation, mean absolute deviation will be MAD will be sigma modulus EI divided by N. N is the total periods, that is 10. That is 42 by 10, it will be 4.2. Similarly, mean forecast error, mean forecast error will be MFE will be sigma cumulatively we have to add algebraically or cumulatively, it will be 8 by 10, that is 0.8. When you put this modulus without bothering the sign, only magnitude you have to take. So answer will be 4.2 and 0.8. Mean forecast error is 0.8, mean absolute deviation is 4.2. First you have to calculate the error, 430 minus 22 plus 8, like this. So each one you have to calculate, we have to add, without considering the sign, we have to add the modulus, then it will be 42. For calculating the mean forecast error, it is sigma EI, we have to cumulatively add, considering the sign into account. Okay. Here while when I keep the modulus, only we have to consider the magnitude, no sign. Okay. Answer will be here, the 1000 is the best order size. Here the tail even slack will be 0, head even slack will be 2. The critical path, CPM path this is. And this one is the economic order quantity, EOQ, inventory EOQ. This every time inventory one question will come. Material science one question is asked, in which of the following processes steel is heated to the lowest temperature? Answer will be nitrating. All are meant for the surface hardness, for surface hardness of steel. But for the lowest temperatures, this is the most appropriate answer. All for surface hardness, but this is the correct answer. Only one question in the material science. Now actually if you just look at the overall pattern of the examination, if you see, no question is too complicated. Most of the questions are average, below average or average only. So I will rate the entire question paper would be below a moderate, easy to below moderate level, and on 16th coming after 2 weeks, most of the people may be rating XE also, where fluid mechanics, thermodynamics, mathematics, aptitude will be there. But those questions which will be asked in that XE paper, because mechanicals would also, most of the people will write either PI or XE. When you are writing XE, be careful that the fluid mechanics and thermodynamics questions asked in XE will be much more tougher than the FM and TD what they ask in the gate. So, with all this discussion, I can say that this time cutoff will be definitely more, and because paper is relatively easier, most of the people may get a good score, even with a reasonable preparation. So, I hope you would be doing the good for the XC paper also. After that, some people may be writing engineering services. I will come back for the XC paper also. XC paper also discussion I would like to come back for discussing fluid mechanics and thermodynamics, which is being conducted on the 16th. Now the my colleague ex ISRO scientist Dr. Ranganathan sir, senior scientist, retired scientist from ISRO, Ranganathan sir will be discussing mathematics and aptitude after a few minutes. I wish you all the best, guys. Actually, would like, in fact, any doubts if you are having, you may contact me on this number. This is Sekhar from Msigma Gokulam. Because my experience in GATE is very vast. Most of the teachers which are working in big corporate institutions, earlier they were my students only, sometime or other during about 10-15 years back. So my experience is vast. Any doubts if you are having, you may contact me over this number. I am Sekhar from Msigma Gokulam. So now my colleague Dr. Ranganathan sir will be coming here to discuss maths and aptitude. Wish you all the best, good luck for your future endeavors, but remember that with this GATE preparation you can try any kind of examination wherever, whatever you would like to write. Need not be GATE, any lower level examination, like after soon you will be writing the ISRO or DRDO or a BARC, whatever it is. Once you prepare well for the GATE, it is one answer for so many questions. So I wish you all the best for future endeavors. Good luck.
Hello friends, GATE 2025 ME Engineering Mathematics and General Aptitude. The questions were very simple and easy for all the people. Okay, you might have done very good way, I think. So we will do one by one. The first question is, if two unbiased coins flip together, then what will be the probability for coming at least one head? So now we have to write the sample space. Sample space means what? It is a set containing all possible outcomes. So here the outcomes are HH, HT, TH, TT. So totally 4 points are there. So now what they have asked is, what is the probability for getting at least one head? So the favorable points are 3. Therefore the required probability equal to 3 by 4, which is equal to 0.75. Okay, because at least one head they have asked. At least one head means one head can come and two heads can come. So 3 events are favorable out of total of 4 points. So the required probability is 0.75. So the next question is, these are all general aptitude question. HIDE, hide. The number is 19, 28, 7 and 11. And similarly another word CAGE, this is decoding. Decoding basically, CAGE, that means C is 8, A is 2, G is 17 and E is 11. Then what is the value of height? That is the question. If you are seeing, okay, solution, here H is 19, isn't it? The first one, H. And if you are seeing E, that is the last one, which is 11. Okay, which is 11. That is the last one. Now we want to find the value of, or the number, the value of height, HIGH. So definitely the first number will be 19 and the last number also will be 19. So in the options, you have to select 19 starting and ending, ending also 19. So the answer will be B. The answer will be B. So the third question is, okay, this is final year students are attending internship at company S and company T. There are two companies where the students are attending internship. The probability of a student interning at company S is 0.8 and the probability of a student interning at a company T is 0.6. The probability of a student interning at both companies is P. Okay, which of the following ranges is correct for P? Okay, so this is very simple, right? So there are totally two companies, S and T, right? The intersection is P. Okay, the intersection is P. So now it is given for interning at S is 0.8 and interning at T is 0.6. So we know the sum of all these three two sets together is 1. Okay, so this is 0.8, this is 0.6 they have given. That means okay, right here, okay, roughly I will do P of A union B equal to P of A plus P of B minus P of A intersection B, right? That is 1 equal to 0.8 plus 0.6 minus P of A intersection B. So if you are seeing A intersection B, it will be 0.4, it will come, okay, 0.4. So this will be 0.4. That means this will be 0.2 and this will be 0.6. So that the sum will be, write as 0.8 internship, okay, and that is 0.6 internship is okay, and this is 0.4. That means 0.2 and this will be 0.4. So that the sum will be equal to 1. So the correct answer will be option B, 0.4 less than or equal to, because this 0.6 can come inside the first set itself. So 0.4 less than or equal to P less than or equal to 0.6. So the next question is, if two person P and Q are moving at point X at 10 a.m. and P moves in north at a speed of 30 km per hour and Q at a speed of 25 km per hour in the east. Okay, if P stops in between for some time while Q moves continuously, at now 11:30 a.m. they both reaches at the same distance. For how much time P will stop? That is the question. So this is a general aptitude question. Okay, right. So now okay, the solution. The solution can be like this. Okay, both people are starting. Now this fellow 30 kilometer. 30 kilometer per second, 30 kilometer per hour, I think, 30 kilometer per hour, and another fellow, he goes 25 kilometer per hour. So now this man, he stops for some time, whereas the other man goes further. Okay, at 11:30 a.m., that means at 1 hour at 11 o'clock, this fellow will be at 25 kilometer and this fellow will be 30 kilometer. Right. Now another 30 minutes this fellow is traveling. So now this will be 12.5. That is, this is 11:30. One person's distance will be 25 kilometer 1 hour and another half an hour it is 12.5. Now this fellow rests and the remaining distance he has to cover. So how much? Now it is how much? Now this is so the required will be, now already he has covered 30 kilometer, so 5 kilometer is there, so the remaining is 7.5 kilometer he has to cover, divided by the speed of this fellow, which is 30 minutes, 30, and this is equal to 15 minutes. Right, he will take another 15 minutes so that both will be at the same distance. So the next problem is increasing number of mirror images producing lines for the geometrical figure. Isosceles triangle. Isosceles means what? Two sides are same in a triangle. Next one is equilateral triangle and the third one is square. Equilateral means all the three sides are equal and the third one is square and the fourth one is a circle. So if you are coming here, there are two images for the first fellow, that is the equilateral triangle. Okay. 1 minute. Okay, the isosceles triangle. So here it will be 1, right? And this will be the equilateral triangle. There are 3 lines of symmetry. Okay, 1, 2, 3, right? That is this is 30 degree line is drawn. So that symmetry you can obtain. Symmetry means what? That mirror image means what? About this line, the mirror image will be same. So if you are taking this line, the mirror image of this and this will be same. So this will be one line and this will be 3 lines. Now coming to the square, all the 4 sides are equal. There will be 3, 4, 5, 6. Okay, and this will be symmetry will be 4, and this circle means any diameter. Diameter will be the mirror image it will get. So this is infinity. So this is the order. The first one will be the isosceles triangle, and the second one will be the equilateral triangle, and the third one will be 4, that is square, and finally that is the infinity. So the next problem. So we are going to the engineering mathematics, right? There was 8 questions, 8 simple questions from each topic, starting from linear algebra, calculus, vector calculus, ODE, probability, and numerical, and then complex. All the 8 chapters were having 1 question each. The first question is from the ODE, right? Now this is x square d square y divided by dx square plus 3x divided by dx plus y equal to 0. Now this is nothing but the Euler homogeneous equation, because x square has come when the second derivative was there, is there, and x has come in the first derivative is there. So the method as you know, it is very simple. We have to put let x equal to e power z, and therefore z equal to log x Okay, and there will be x into d by dx equal to d by dz, which will normally will call it as say d. Okay, and x square d square by dx square equal to d into d minus 1. Okay, where d is nothing but d by dz, where z is the independent variable. Therefore, the given equation becomes what? D into d minus 1. Next one is 3d plus 1 of y equal to 0. Implies now this is d square plus 2d, d square minus d plus 2d plus 1 equal to 0. Okay, the problem is correctly written or not, I will check. Right. Okay, d minus 1, so that is nothing but d square plus 1 the whole square equal to 0, implies what? D plus 1 the whole square equal to 0, right, implies what? D equal to minus 1, that is the repeated root, as you know. Therefore, the solution is what? Y equal to C1 plus C2 z into e power minus z for the repeated root. Now this is equal to C1 plus C2 log x. Okay, z is nothing but log x. Okay, and e power minus log x is what? X raised to minus 1. So now the solution is what? C1 by x plus C2 log x divided by x. This is what the solution is. Okay, now we have to use the boundary condition. Now we have to use the boundary condition. Y of 1 equal to 0 implies what? 0 equal to C1. Right. Y dash of 1 equal to 1 implies C2 equal to 1. You have to find y dash from y. Okay. Right. Therefore, the solution is y equal to log x divided by x. This is what the solution. Okay, alright. Therefore, y of 2, that means when x equal to 2, what is y? What they have given is, it is a log 2. This is what they have given. Implies a log 2 equal to log 2 divided by 2. Right? Which implies a equal to 1 by 2. 1 by 2 is the answer. You have to do by yourself so that you will get the correct answer. Right. So the next question is, if players P and Q plays a chess game, the probability of P winning is 80%, drawing is 15%, and losing is 5%. If they play 3 more matches, what is the probability that P wins exactly 2 games? Okay. Right. I have done this. Right. What they have given is solution given P winning. Okay, that is what P winning is what? 80%. 80% equal to what? 80 divided by 100. Now this is 4 by 5. This is what they have given. P of losing how much they have given? Winning is this, drawing 5%. 5% means what? 5 divided by 100. Now this is equal to 1 by 20, which is equal to 0.05. Okay. And P drawing how much? 15%. 15% means what? 15 by 100. Now this is 3 by 20. Now this is equal to 3 by 20. Okay. Now this is equal to 0.15. Correct. 0.15. Right. Now, what is the question is, if they play 3 more matches, what is the probability that P wins exactly 2 games? P wins exactly 2 games. Here we want to win, that's all. Alright, here we have WWL, that is the first one, comma, right, WLW, that is the second one, comma, and LWW. This is one possibility with the 2 wins and 1 loss. And next one is what? WWD. WWD, comma, right? And next is what? Drawing. WDW and the finally DWW. Okay. These are the 6 possibilities for 2 wins. Okay. Hence we have, so we have to write the probability. That's all. Right, for each one. Hence we have WWL. What is the probability? W for winning probability is 0.8. Isn't it? 4 by 5 means 0.8. Okay, 0.8 into, right, another 0.8 into, and L losing is 0.05. This is what the probability. All the 3 has to happen. And this is WLW. That is, W is 0.8, losing is 0.05 and winning 0.8. And the next one is LWW. That means 0.05 into 0.8 into 0.8. And the next one is WWD is 0.8 into 0.8 into drawing. Drawing is 0.15. 0.15 is, I think, 0.15, yes. It is 0.15. And the next one is WDW. That means 0.8, 0.15 and 0.8. And the last one is DWW. That means D is 0.15, 0.8 into 0.8. So now we have to add all the things, because either this can happen or this can happen or this can happen. Therefore, adding we get the required probability. Adding, we get the required probability. Adding, we get the required probability equal to, okay, I have calculated that, which is equal to 48 by 125 if you are using the fraction, and this is decimal is 0.384. That is the answer for this. Okay, very simple problems. Okay, if A and B are symmetric matrix with the same order, then A transpose equal to A minus 1, AB equal to BA, AB transpose equal to B transpose A transpose, and finally A equal to A minus 1. We will take one by one. Okay, the first, write A, let us say, right. If that is the orthogonal property, if a matrix is orthogonal, what is the definition? A transpose equal to I, which implies A transpose equal to A minus 1. So the option A is not correct. A transpose equal to A minus 1 means it is an orthogonal matrix. And the second condition, B, in general, multiplication in matrix theory is not commutative. In matrix theory is not commutative. So AB equal to BA is not correct, not commutative. Okay, so option B is also wrong. And C, option C, if you are taking in general matrix theory, okay, in general matrix theory, AB transpose equal to B transpose A transpose. Okay, only we have used same order, that's all. Symmetric we have not used. Hence, option C is correct. First information, option C is correct. Okay, then go to the option D. Option D, a matrix, a square matrix is involuntary if A square equal to I, right? Involuntary. That is A into A equal to I. But therefore, A equal to A minus 1. Okay? That is the last one. So the correct answer will be C, right? But we have not used the symmetric property. If it is symmetric means B transpose equal to B and A transpose equal to A. Okay, so this they should have given BA. Then Okay, anyway, in any general matrix theory, AB transpose equal to B transpose A transpose. The first one is orthogonal property and the second one is commutative, which is not correct, and the last one is involuntary matrix. Okay, the next problem is in calculus. What is the maximum value of f of x? So, okay, solution. Given what? F of x equal to 2x cube minus 9x square, 9x square plus 12x, comma, the interval also they have given. Okay, so what normally we will do? F dash of x equal to 6x square minus 18x plus 12. F double dash of x equal to f double 12x minus 18. Therefore, stationary points are given by f dash of x equal to 6 into x square minus 3x plus 2 equal to 0. Implies x minus 1 into x minus 2 equal to 0. Implies x equal to 1 comma 2. So this is the stationary point. For all problems, we have to find what is the stationary points. Okay. Now at x equal to 1, okay, at x equal to 1, f double dash of x equal to what? F double dash of x equal to less than 0. Because 12 minus 18, which is less than 0. Therefore, x equal to 1 is a maximum point. Therefore, the x equal to 1 is a maximum point. So, they have asked that one only. Therefore, maximum value. Therefore, maximum value equal to f of x equal to what is maximum value? 2 minus 9 plus 12. That means 14. 14 minus 5, that is 9. So, this is one maximum value. Okay. At x equal to 2, we have f double dash of 2 equal to what? F double dash of 2, what, greater than 0. Isn't it? 24 minus 18, greater than 0. Therefore, x equal to 2 is a minimum point. Right? So, this is called local maximum, and that is called local minimum point. Okay. But the interval they have given. We have to find that end points value also to get the global maximum and global minimum. Here, f of 0 equal to what? 0. Okay. And f of 3 equal to what? F of 3 means what? This is 27 into 2, 54, I think. Okay, you check the value. Minus 9 into 9, 81. Minus 9 into 9, 81. Plus 36. Plus 36. Okay, I think I am correct. 27 into 2, 54. That is 9 into 9, 81. Now this will be how much? 60, 90, which is equal to 9. Okay, what is the maximum value? You find it. Maximum will be 9. So, hence, out of all these things, hence maximum of f equal to 9. Suppose they have asked minimum, means what? And minimum value of f. So what is the minimum? Minimum at x equal to 2, one minimum is there, and here 0 is there, and here it is 9 will be there, and this will be 0, 9, 4, which is equal to 0 will be the minimum value. So the next question, one partial differential equation is given, and the solution is given. Which one is the correct one? The best thing is what? Substitute and find it. That's all. One simple solution. Okay. Option A implies. So now this is called the Laplace equation, del square E, del square U. Option A implies del square equal to, that is dou square U divided by dou x square plus dou square U divided by dou y square. And what it will give, if you are differentiating twice, what happen? One is sine will become cos, and then cos will become minus sine. You are getting the first term as sin x minus sin y, and the second term also sin x minus sin y. So this is not correct. You are not getting 0. Option B implies, alright, dou square u divided by dou x square plus dou square u divided by dou y square equal to. So differentiate twice with respect to x. E power x into sin y only you will get. And differentiate with respect to y twice. Right? Y twice means sin will become cos and cos will become minus sin. So totally you will get e power x minus sin y, which is equal to 0. This is not equal to 0. Whereas the second one will become 0. Option C implies what? Dou square u divided by dou x square plus dou square u divided by dou y square equal to cos will become minus. Then totally you will get minus cos x minus cos y, and the second one is also minus cos x into cos y, which is not equal to 0. And finally option D implies what? Dou square u divided by dou x square plus dou square u divided by dou y square equal to, now this is e power x into e power y. Twice if you are differentiating, you will get e power x into e power y only. The second one is also e power x into e power y, which is not equal to 0. So the correct answer will be B, right? And you can do by complex analysis method also, right? Or the same thing, I will give hint, right? Consider W equal to e power z, right? This is equal to e power x plus iy, which is equal to e power x into cos y plus I sin y. Cos y plus I sin y. Therefore, u equal to what? E power x into cos y, and v equal to what? E power x into sin y. Here, w is analytic. Right? Here w is analytic function. Therefore, u and v are harmonic. U and v are harmonic. That means what? It will satisfy the Laplace equation. That is dou square u divided by dou x square plus dou square u divided by dou y square equal to 0. So the correct option will be B once again. So the next problem, it is in numerical analysis. They are given 4-5 data points. By using Simpson's 1/3 rule, the approximate integral value is. Solution here, first of all, h. What is the interval difference in x, right? That is uniform only, 0.25, 0.25. Here h equal to 0.25, first information. We know Simpson's rule as. Simpson's rule as, right? What is that? I equal to h by 3, first value plus last value, y0 plus yn, plus 4 into odd values, y1 plus y3 plus etc., plus 2 into even values, y2 plus y4 plus etc. So this is what the Simpson's 1/3 rule. This is equal to 0.25 divided by 3, first value plus last value, that is 0.9 plus 0.4 plus 4 times y1 2, 2.0 plus 1.8, and the next is 2 times 1.5. All the data has to come only once only, that is the answer. Okay, it should be, it is 1.625, that is the answer. Okay, probably this may be the last for the given expression, right. So now the first thing is this may be 2 pi I n, right, and the values of n is, okay, this may be, okay, n is, and they are given C semicolon, right, given C semicolon modulus of z equal to 1, right. The unit circle also they are given, that is not typed, and probably this may be multiplication, right, probably this may be multiplication. Okay, this is the corrections to be incorporated in this typing. Solution, let. So what we will do normally, let f of z equal to z cube divided by z square plus 4 into z square minus 4. Okay, that is the first one. Here the poles are given by denominator. Poles are nothing but singular points. Here poles are given by what? poles are given by Z square plus 4 into Z square minus 4 equal to 0. That is the denominator equal to 0. Therefore, Z equal to plus or minus 2i, comma plus or minus 2 are the singular points, are the poles. Right? Right? So now this is Z equal to plus or minus 2i lies in the imaginary axis, and Z equal to plus or minus 2 lies on the real axis. Clearly, both the poles lies outside the given contour. Lies outside the given contour. C semicolon modulus of Z equal to 1. Therefore, by Cauchy's residue theorem, integral C f of Z dz equal to 2 pi I into 0. 2 pi I into 0, which is equal to 0. Right? By sum of the residues at the poles inside the given contour. Right? Given, what they have given, integral C f of Z dz equal to 2 pi I into n, which is equal to 0 in our calculation, which implies n equal to 0. That's all. This is the answer. N equal to 0. So the first correction is 2 pi I n, and this may be multiplication, and this is given the contour. Contour has to be given. Where is the contour? The contour is C semicolon modulus of Z equal to 1. Okay. Now we are going to the English. There are two problems were there. One is first fish is solved, and then lion. The answer will be pride. Okay, I have written. Okay, solution. Shoal. SHOAL means what? A large group of fish. A large group of fish that feed and swim together. That feed and swim together. This is what they have given the first one. That feed and swim together. That is, fish means a large group of fish that feed and swim together. Then what about lion? Lion means in this forest is not correct, school is not correct, series is not correct, and the correct answer will be pride. So if you are seeing the dictionary, pride means what? Is a social group. It is a group of lions. Is a group of lions. Is a group of lions that live together. That live together in a specific territory. In a specific territory. Okay, so the correct answer will be pride. All the three remaining things are not correct. Okay, find the correct sentence. It is I who is responsible for this fiasco. It is I who are responsible for this fiasco. It is who. So who is correct? Then it is I who is. No, that is not correct. It is I who, or it's not correct, and it is I who I am responsible. So this is correct and this is wrong. Okay friends, I hope you have written all the questions very nicely. Engineering maths as well as the general aptitude are very easy and simple problems. Okay, good luck. That's all.